Okay, let's get into it, shall we, guys? All right, so welcome to your first day on the job learning how to be computer animators. Last week was kind of an administrative week as we went through all the really important little chunks of information that allowed us to manage and kind of facilitate this class. But today, in every sense, we're going to jump in and start learning the animation process. Going forward, Canvas is going to be our primary method of communicating a tremendous amount of information to you guys. Okay? In addition to getting direct access to the homework and the lab assignments that we're going to accomplish every week, it's also going to be a landing spot for all of our major course content, all the learning resources. And if you cruise over to your module section on Canvas, you can see that I've already added in this week's homework assignment and lab work. We'll come back to that in a minute. And then down here at the bottom, check it out. A whole bunch of directed, individual, short little videos that talk about laser-focused subjects that we're going to cover today. So use these videos as kind of like a little small video encyclopedia. If you have a question, come back here. Get used to returning to this part of the Canvas section here to get that stuff that you have questions on. The live streams are pretty great. They're fantastic resources, but in every sense, they're exactly what you think they are. They are just kind of, just these, hour and a half to 2 hour live streams of our entire class, right? Sometimes you don't want to have to wade through the entire live stream to find that little nugget that you're after. These videos, in every sense, are those nuggets, okay? So come back here. Remember that this stuff is here and continue to use them as you start to learn the process of animating inside of Modo. They're all really great. They're all videos, by the way. The ones that you'll probably absolutely need to come back and revisit are these bottom three. Okay? These bottom three, the creating keyframe animation, rendering animations in Modo, and rendering image sequences in After Effects are, this is where the rubber meets the road on a lot of levels. So they're important little videos to come back and take a look at. And they're just videos. Okay? So you get to go home, and you get to come to class and listen to me, and then you get to go home and listen to me. How awesome is that, right? Okay. Let's take a look at what we're going to be striving to accomplish this week. We have two big missions. First and foremost, our homework is going to be an animation called the solar system. And I've given you a small little simple start file down here at the bottom. And your mission is to make all the planets spin around their appropriate orbits. We'll talk a little bit more in detail about what that looks like here in a minute. In every sense, the solar system project gives us a great opportunity to learn the computer animation pipeline and get really comfortable rendering in Modo and rendering in After Effects. Okay? This is going to be kind of a two-step process going forward, and you'll see that in detail here in a minute when we get to that portion of the class today. So the solar system. Okay, I've given you everything that you need inside of the link down here at the bottom. And like I said a minute ago, we'll come back and look at this in detail here in a second. Okay, if we return to the Week 2 module, we also have a small lab assignment that we may start in class today. It's called the coin flip assignment, and I've actually given you guys a great small example animation of what we're striving to complete. Well, that's it. Okay, very, very basic. We're going to start off with simple, little, meager beginnings as we begin our adventure to learning this new art form. Okay, believe it or not, just flipping a coin and having it move from the left side of the screen to the right side of the screen requires some energy and effort, and we're going to be looking at that directly today. Sound good? You ready? Ready to jump in, start rocking and rolling? Okay. Now, I know many of you in here have some experience working inside of Modo. Others do not. So let's just take a second, step back for a moment, and look at the general Modo process. Let me turn off some lights for here real quick. There we go. So we're going to be using a program called Modo, and specifically 10.2. It's the version of Modo that we're going to be using in this class. You can find the icon way down here in the dock. It's a little swirly thingamajig here next to the big XD icon in our dock. Okay. If you click on it, if you click on it, naturally the icon's going to jump in the dock a couple times before the application launches. It's a big app, so give it some time. At times, it just takes some energy for the app to launch, okay? But once it does, and it knows it's Friday morning too. It's just taking its merry old time today. Modo's already ready for the weekend. Here we go. Welcome to Modo, okay? Your new home away from home for the next now 15 weeks of our academic semester. This is where we're going to be spending all of our time building our computer animations. As some of you already are very comfortable working inside of Modo, some of you are not, so let's just kind of start looking at the basics. Okay. Now the Modo interface is pretty fantastic. It's a plastic interface, meaning we can customize and move it around and change how this interface works. But there are some major zones within our interface that we need to have some understanding of. First and foremost, if we go to the top of the screen, we have all these tabs. Check it out. All of these tabs. These tabs are going to change our interface ever so slightly. These are called layouts. And these different layouts bring to the surface or the foreground certain tools and certain workflows that promote an idea. Like, for example, right now I'm sitting in the modeling layout, so I have all my modeling tools at my disposal. If I was to go over into the paint layout, then I could do some 3D painting. And naturally, for an animation class, we're going to be spending some time in the Animate tab. Okay, so if we click on that, here's our animation environment, which is pretty fantastic. In addition, we also have a Render tab up here at the top, which is where we're going to be asking the computer to draw some animation frames for us. If you don't see this gigantic bar up here at the top, don't worry, it's still there. It's a collapsible part of the interface. Check it out. If you click on the big dark area to the left or the right of these tabs, whoop, it expands and collapses. You return to it, you can see a little cursor, or the color change there, excuse me. You can click on it and it comes back. Okay? So it's not ever really gone. You can't break it. You can't delete it. It's always there. But you can expand and collapse it. Just keep that in mind. One of the things that you're going to learn to love about taking classes with us here is that it's kind of the wild, wild west when it comes to these labs. I teach five different classes here this semester. And let's see, 4 of those 5 are all on Modo. So you never really know who's going to change Modo, who's going to be sitting in this chair earlier in the week, what they've changed in the interface. So it's really important that we have an understanding of these small little interface changes that can affect your ability to produce and to work inside the application. All right, so we got all these layouts up here, which we'll continue to talk about as we go through the semester. However, let's just jump into the modeling tab real fast, because I think the modeling tab does a great job of letting us understand and visualize some important big concepts and those other zones inside the interface. Over here on the right, that's not the right, the other right, over here on the left, all of this jazz, okay? That is the toolbar in the modeling layout. So we're only ever going to find tools, and as you can see, there are a bunch of them. The guys and gals down at the Foundry have done a really great job of figuring out how to organize and categorize all their tools into very logical categories. So we have the basic tools, here's all of our duplication tools, for example. So these vertical tabs are a convention that you're going to continue to see throughout the interface. That's how they stack panels, if you will, inside of Modo, and it's pretty easy to find what you're looking for, but you just got to, visually got to understand that these are tabs over here as well. Now, for the most part, we're going to be hanging out in the Basics tab. The Basics tab is kind of like the rock star tools, the all-stars, the ones that we're going to be going in and out of the most, okay? So keep an eye on that Basics tab. Now, we're going to jump here real quick. We're going to jump over this center viewport and come way over here to this side of the screen. Now, in the animation world, this portion of our interface is actually going to play a really big role. The right-hand part of your interface is kind of like a utility area where we can access a list of all the different items that are available and are currently influencing our three-dimensional scene. And then below that, if you keep cruising down, heading south inside the interface, we also get a whole series of properties. So whenever we select an item down below, the properties for that item are going to be drawn to the surface. You'll see this in detail here in about, 30 minutes when we really start leveraging the power of the item list, that little list on top, and their corresponding properties down below. All right, so the left-hand part of the interface, all of this stuff over here, these are almost always going to be tools. And the right-hand part of the interface, these are going to be utilities, okay? Panels and windows that bring to the surface kind of a little bit more technical information about how our scene is constructed and what's influencing the animations in our world. The last thing is probably the most important part and it's this thing in here, okay? This is our viewport. Our viewport, in every sense, is like a window into our scene, okay? Imagine that we are out in space, okay, and we're chilling in like the International Space Station. Space is an infinite void, right? Infinite. It goes on forever, right? There are no boundaries. Our viewport is very similar to that. It's infinite space. There are no boundaries. Let's put something in here so at the very least we have a point of reference as to what's going on, okay? Let's do this. I'm going to go to the top of the screen where it says Geometry. And under Unit Primitives in Current Mesh, let's create a teapot. A simple little teapot, okay? Let's throw it in there real fast. And there it is. There's our cool little teapot. Now, if your teapot is really, really small inside the frame, let me introduce you to your probably most favorite keyboard shortcut going forward, and that is the A key. The A key is going to fire off AutoFit, and it's going to frame all of the items of our three-dimensional scene into one area. So check it out. So if you see your teapot like this, I'm like, where's my teapot? Hit the A key. Boom, there it is. A for AutoFit. Okay, now that we have something inside of our world, we can start looking at it. Just keep in mind, we're an astronaut, if you will, on the International Space Station. Okay? In the world of 3D, our objects are like sculptures, if you will. They're statues that fundamentally don't move. We, as the user, move around them, kind of like going back into space, right? Have you guys ever seen those little jetpacks the astronauts have? They literally have jetpacks, which is awesome, right? They're kind of big and bulky. I've always wanted to do that, by the way. I think that'd be just like the coolest thing in the world. Like when I win the lottery, and I'm just going to say when because I believe in the power of positive thinking. When I win the lottery, I'm buying myself possibly a round-trip ticket to space, okay? Because beam me up, Scotty. I'm ready to go. Let's do this, okay? And those little jetpacks the astronauts have, they have little controls on it, they like tool around the outside of the International Space Station, right? And, okay, the space station is static. It doesn't move, but the astronaut goes around it, so we can see every part of the space station from the outside. We're kind of doing the exact same thing here in 3D. The teapot is like our space station, and what we are seeing is the view of our space station through the visor of our astronaut helmet, okay? So the space station is static, and our perspective of our three-dimensional scene is changing, right? So our objects don't move, we move, okay? Everything is a statue in our world, and then we move around it. Which brings up the next question, how do we move around our scene? How do we inspect our little teapot from a number of different angles? Well, let's check it out, right? There are a whole series of viewport navigation commands that you're going to need to master. Before we get too much further into it, I think it's really important to point out that we are two-handed operators, okay? You have to have a hand on your keyboard, and the other hand's going to be on your mouse. This isn't like one of the Adobe apps where you can just kind of casually one-hand drive this bad boy, right? No, in the 3D world, 10 and 2, man. 2 hands on the steering wheel. 1 hand on the keyboard, the other hand on the mouse, okay? Now for me, I usually kind of have my thumb just chilling on the command key, which forces my left hand over to the area of the keyboard where all of the keyboard shortcuts really are kind of placed, okay? So let's just do it real fast, okay? With 1 hand on the keyboard, the other hand on the mouse, I'm going to hold down the Option key and then left-click and drag with the left mouse button. You can see that we're performing what's called an orbit.
Also, a quick note for the people who are noticing that their computers are doing this weird turning thing.
Let's not get to that quite yet. So if you hold down the Option key and left-click and drag inside of your viewport, you're going to fire off what's called the orbit. And I'll write it on the board so everyone can remember what these keyboard shortcuts are. Earlier in the week, I had a black marker. So there it is. So Option plus left mouse button is going to equal the orbit command, okay? That's going to allow you to rotate your perspective of our three-dimensional scene around and around. Now, when we pair the Option key with the Shift key, so Option plus Shift and left mouse button and drag, then we're going to perform what's called a pan, where our relative position to the teapot is going to go up, left and right, up and down. It's almost like as if we're moving, but we're not rotating. That's called a pan. Option key, left mouse button drag, orbit. Option Shift, left mouse button and drag is the pan. I'll write on the board so folks can see. So Option plus Shift plus left mouse button equals pan. And then last but not least, once again, if we pair the Option key with the Control key, what function are we going to fire off? The zoom. You got it, the zoom. Okay? So those are our three basic keyboard navigation controls for our viewport. Okay? We want to use them as much as we can. Everyone just take 2 seconds, if you're new to working inside of 3D, and get really, really comfortable working inside of this environment. Just take 2 seconds. Get comfortable with it. Orbit around. It takes some practice, right? It's like driving a car. You know, unfortunately, in the world of 3D, we have to fail 10,000 times before we're good at anything. Okay, that process of failure begins today. Yes, ma'am?
For some reason, the Shift and the Control commands just start working.
Okay, hold on the Option key. Option Shift. There we go. Yeah. If you look at the keyboard navigation commands, what's the common denominator between all of them? The Option key. Yeah, the Option key is going to be a major fixture for us going forward. Okay? So keep that in mind. Keep that in mind. You know, for me, usually I have my index finger just sitting on the Option key. Okay? So we're using it every other second. This isn't like an Adobe app where you can kind of fly with just the mouse. Okay? We are forced to use the keyboard and the mouse. That's just part of our workflow. Okay? So get used to working with 2 hands on our input devices. It's going to be really helpful. Okay. So with these keyboard navigation commands in tow, we can do some really cool things. We can inspect our teapot from any angle. We can get super close, check it out. However, if you're noticing that the orbit is behaving slightly differently than what you're seeing on my screen, where it feels like you're kind of twisting this way, you're rolling through space, let me show you one thing that will help you out. Inside of Moto, we get to control how this viewport behaves through a whole series of viewport properties. Now, please note that my cursor is currently inside of the viewport. So when I hit the O key, I'm going to open up the viewport properties for just this viewport. This is what it looks like. This is called a popover form inside of the Moto world. And this little form here has all sorts of information and commands that will allow us to customize how this viewport is going to behave. Okay? Now, there's some interesting things in here. Specifically, I want to head over to the Drawing and Control tab inside of our viewport properties. So the first vertical tab over here on the right. And if we take a look at it, it's a pretty big form. Down here at the bottom, we have a section called Mouse Control. We have an option here that says trackball rotation. Now, the defaults are going to enable trackball rotation. I suggest turn it off. Put that option to no, and you're going to find that you're going to find that the rotation of our viewport is going to feel a little bit more natural. Okay? As one might imagine, this option is available to us for the artists that are truly using a trackball to do all their navigation. It's actually really kind of amazing how prominent trackballs are out there in the real world. Does anyone know why folks travel to trackballs instead of mice? Most people don't even know where to buy a trackball, right? It's definitely an input device from yesteryear. Have you guys seen a trackball? You guys know what I'm talking about? A trackball mouse? Yeah? Yeah, it's got this big pad, and then it's got a big sphere on it, right? And you just put your thumb on that big sphere and roll it around. It's a trackball, right? Trackballs are really great for ergonomics because the thing that kills your wrist is the angle of your wrist, and then this constant motion, right? And if you think about it on a mouse, we're doing that all the time. We're doing small little movements, left and right, left and right, left and right. That kills your wrist pretty quickly, and it's one of the major contributors to carpal tunnel syndrome, right? Trackballs, your hand is stationary the entire time, and you're just moving your thumb. So a lot of artists, especially in the computer world, travel over into the trackball world just to make sure they don't have to get that carpal tunnel surgery. That's no bueno. Okay, so I turn trackball rotation off, and life is good. Things are looking just absolutely wonderful. As we get more comfortable working inside of our three-dimensional scene, and as we navigate and zoom around and orbit around our scene, oftentimes we're going to get lost. Think about it. You're an astronaut in this infinite void, right? You're in space. It's nothing but blackness. How in the world, in an environment where there really aren't any sort of landmarks, points of reference, if you will, how are we going to keep our bearings? How are we going to continue to understand what's up, what's down, what's left and right, forward and backwards? The guys and gals down at the Foundry have done us a real big favor, and they have given us some very subtle reminders of these very important landmarks and bearings, compass markers, if you will, inside the viewport. We want to be able to communicate with our artists and understand certain parts of our model very clearly by giving them kind of names like this is the top of the model, this is the bottom. But how do we understand and consume that inside of Modo? Let's check it out. Now in 10.2, the guys and gals down at the Foundry have done something really kind of neat. Check it out. If you look very carefully, and I'm just going to deactivate my teapot for a second. If you look very carefully at the center of our scene here, we have that red and blue cross, right? What is that? Yeah, where it intersects is the center of our universe, right there at the center of my screen. Does anyone remember what the center of our universe is called? The origin. Yeah, well, our Modo universe is called the origin. Yeah, and well, I guess have we mapped the center of our universe? I'm not sure if we have. I really don't know. The center of our solar system, pop quiz, is the sun, right? So imagine we're chilling in our solar system. At the intersection of those two lines would be our sun, okay? So that's our first little subtle little landmark here, okay, that reminds us as to where we are. The center of our universe, the origin, is the really only defined landmark, the known location inside of all 3D scenes. It's an important one to zero in on, okay? And it's always going to happen at the intersection of those red and blue lines going forward, which is kind of cool. That's the origin, the center, okay? Now, if you think about it, what we're working with here are a whole series of planes, right? And I'm going to turn a light on real fast so we can start to look at this. And I'm going to ask you guys to go back into the Wayback Machine into 10th grade geometry. Now, for some of you, this is going to be a little bit more of a trip, of a longer trip. For others, it's only going to be a year or two. And in 10th grade geometry, you were asked to plot points along a 2D Cartesian grid that looks something very similar to this. You guys remember this from geometry class? And they had all these little ruler markers. This is the graph that you love to hate, right? Because then your math teacher would put a point on the grid and say, okay, where's that dot? And you had to figure out the location of that point, right? 2 and 3. Now, Christine, how'd you get to that?
Because the x is on the 2 and the y on the 3.
Okay. Let's get more specific.
On the x line, if you
Which is the x line?
the one horizontal.
Horizontal, you got it. Okay, there it is. So we have two axes that we're plotting points along. One is the x, the other naturally is called the y. The x's responsibility are the horizontal values, so it's left to right. The x-axis always represents horizontal values, okay, left and right. And the inverse of that is the y-axis. So what's the responsibility of the y-axis? Up and down. You got it. You got it. So the x is always going to be horizontal numbers. And the y is going to be vertical. Okay, so Christine did the hard part for us. She counted the ruler markers pretty quickly, and she figured out the location of that dot pretty fast, right? Math 120, man. Here we go. So we count 2 over. That's its horizontal location. And then we count up. There it is. 3, 2, 3. That's its vertical location. Okay? Now, this is fundamentally what we're doing here in the 3D world. We're plotting points along inside of a 3D Cartesian grid, right? We're a little bit different because this is 3D graphics. If this was 2D graphics, all we'd have to worry about is the x and y, left, right, up, and down, right? But in the 3D world, we have that third axis, right? The z, you got it, okay? It follows suit. It behaves identically. How would you describe the z-axis? Back and forth. I like that. Yeah. What else? How else could we describe its function and responsibility? Kinda. Yeah. Depth is another great way of thinking about it. Look at it from like this perspective. Okay. If the x-axis is responsible for like left and right, okay, the y-axis is responsible for things going up and down, right? The z-axis is forwards and backwards, right? Forwards and backwards. Now, inside of our 2D Cartesian grid here, and I'm going to just erase the z just for clarity's sake, just to kind of clean things up here a little bit. Inside of our Cartesian grid, it's broken into quadrants, and I'll number the quadrants for you just to make things easy for us to understand. So we've got quadrant 1, this is 2, 3, and 4. Pop quiz, hot shots. Movie quote. Gold star goes to the person who can name the movie. You don't know. Pop quiz, hot shots. No one knows what movie that's from. Oh my gosh, I feel old all of a sudden. Man, it's from Speed. You remember that movie with a very, very young Sandra Bullock and an equally young Keanu Reeves, right? Right? This is a movie where there's a bomb on the bus, and if the bus went lower than 55 miles an hour, it would blow up. Speed! Right? Go check it out. It's actually not a horrible film. It's fun summer popcorn. It really is. Anyways, okay. So pop quiz, hot shots. Which of these quadrants is going to have positive values in them? Exclusively positive values for the x and y axes. 2. Yeah, absolutely right. Quadrant 2, if you think about it, because we count going this way, this is x value 1, 2, 3, 4, and so on. Same going vertically for the y. This is 1, 2, 3, 4. Okay, now on the opposite side of the x-axis, once we cross the threshold past the y, what values are these? Negative, yeah. Now it's coming back, right? -1, -2, so on and so forth. And then going down is also going to be the negative values of the y-axis. I bring this up because understanding the positive side of these axes gives us really good defined landmarks, right? Because think about it. How are we going to describe or communicate to another team member where the top of our model is, right? It's kind of arbitrary if we don't fuel it with some data, with some hardcore information that makes a reasonable connection with what the top is, right? Well, in the world of 3D, the positive side of our y-axis is the top of our scene, okay? So what would be the bottom of our scene? The negative side, okay? Left, positive of the x, right, negative of the x, okay? So how would you describe, or where would you look inside of our three-dimensional scene for the front of something? Positive z, you got it. So if I was modeling a character, for example, right? We always model our characters like this, and you'll see this in play here in a couple of weeks when we start animating characters, right? We always model our characters at what's called the T-pose, which is, the character at its natural, kind of full extremity, right? Well, I want the nose of my character facing a very defined location inside of the scene. What direction should the nose of our character be facing? Positive z, the front of our scene, right? Same goes for the top of the head. If I was to make a line going out at the top of the character's head, where should the top of the head be pointing? Positive Y. You got it. You got it. So now we're starting to get some defined landmarks that help us understand where we are and what we can, or where certain portions of our model are located inside the scene itself. Now, the crew down at the Foundry have done a great job of reminding us about some of these really important, little details. Now, if you look very carefully, there's one gigantic thing inside our viewport that reminds us of up and down. What would be that one thing? The what? The grid actually doesn't run along the y-axis. That light gray grid is something else. But there's something inside of our viewport that... Go ahead. There's not. There's actually not an indication of the y-axis. But there's an indirect representation of the y-axis. The light to dark, absolutely. That's it. That gradient in the background, right? Think about it. The crew down at the Foundry have basically recreated the illusion of up and down through a gradient. The lighter areas of our scene is what, you think? The sky is the top. And the darker areas of our gradient down here at the bottom of our viewport kind of represents the ground, if you will. So up and down is highlighted by this gradient. So now I'm looking up, and now I'm looking down, okay? So pay real close attention to that. In addition, if you look very carefully, if you're confused as to which way you're facing, like right now on this side of my scene over here, which way am I facing? Is this the front of my scene or the back of my scene? The front. We know this, because check it out. They've given us a little marker. Yeah, positive Z. They've said this is the front. This is the positive side of the Z-axis. So this is naturally the front of our scene. Okay? Look for that. You'll see these little markers for the Z and the X-axes on the grid. They'll show you both positive and negative values for them. You can see there's a negative X way out over there. So in every sense, we're looking towards the right of our scene now. Okay? All right. Let me zip around a little bit and get everything kind of where I like it to be. Now, there's one other thing that's going to help us understand and keep our bearings. And it's probably the thing that I use the most to very quickly just understand up, down, left, and right. And it's the compass in the bottom left-hand corner of our scene. This is something that you need to kind of keep in your periphery, especially if you're confused as to what part of the scene you're looking at. Okay? It's going to orbit and change its orientation as you orbit and change your orientation. I think of each one of these lines like a direction arrow. They're always pointing. Here's a good little question. What part of each axis are those little lines pointing towards? The positive. Yeah, absolutely. So they're like gigantic direction lines towards the positive sides of each of those axes. So I just know by looking at the compass which way's up. Point to it inside the... Yeah, up. Up is this way towards the ceiling right now. The Z-axis is kind of like, back towards that corner. And then the X-axis would be going out the window or out the door here. Okay? So the compass is a great tool for us to help understand left, right, up, down, forwards, and backwards. Okay? Use it. Don't ignore it. It's there to help. It really does. It's a great tool to keep everything going. All right. So I put my teapot back in here just to kind of keep going. Now that we understand the basics of working inside of our viewport, let's talk about the basics of working inside, or the basics of working with an object. Okay? Because we want to do some stuff in here. We want to go in and start moving things and rotating. It's just not all about viewing a simple sculpture. We're here to build something, right? And in the context of this class, you're here to build an animation. So we need to select stuff all the time. Modo has a pretty impressive selection engine. I've worked in a lot of different 3D apps over the years, and honestly, I think Modo has the best selection engine. It's quite great. Okay? However, there's an underlying principle that one has to understand before we jump into it. And they take, if not borrow or / steal, this principle from Photoshop. if something's selected inside of Modo, you're going to move it, right? You're going to edit it, right? That's the one thing that's going to be changed inside the scene. If nothing is selected, everything is going to get changed, okay? And it's a principle or an idea that we directly take from Photoshop. So let's talk about the selection engine so we can see how we can manipulate our 3D models and characters here inside of our viewports. And it's pretty easy. As one might imagine, left-clicking on an object will select it. Now, we have to also keep in mind that we're selecting things inside of a hierarchy. There are many different things that we can select and at many levels inside of our system, okay? Let me show you what I'm talking about here. Modo, and all 3D apps for that matter, work inside of a hierarchy of different objects or elements or items, okay? Okay. So when I say hierarchy, what in the world am I talking about? What's a hierarchy? Good question, huh? A thing, yeah. Yes, a thing where people are higher than other things. Yeah, absolutely, right? So if we were to go back in time a couple hundred years to the good old medieval era, perhaps there is a king or a queen, right? They're the highest and most important person in that land, right? So they are the top of the food chain, and then slightly below them would be like, I don't know, a Grand Master Wizard or something. I don't know, right? Merlin is going to be the second in command. And then under them would be like the Knights of the Round Table. And then under them it would be like, I don't know, the cook or something, because food's important. And then slowly but surely you have this hierarchy at the very bottom. I always loved this. At the very bottom of the hierarchy there are serfs, which I always thought was really interesting from history class. Serfs, that's the name of like the peons out in the fields that are just, workers, general workers, right? A hierarchy. Well, we work with inside of a hierarchy here in 3D as well, okay? Think of it like this, okay? A hierarchy that you see all the time and that you interact with all the time would be like your car, right? Your car is nothing more than a whole series of component pieces hierarchically combined together to make a car, right? A car is just a representation of the total sum of all of its parts, right? What would be some of the child components of a car? Some of its component pieces. Like the tires, the engine, the transmission. Of course, you got to have a banging stereo, right? All required components of a car to make it go, okay? Individually, these things have their own role, but when we combine them into a hierarchy, we now have a car, right? We're doing the exact same thing here inside of Modo, okay? Now, the top of our hierarchy, the king of our castle, is something called an item. This is really important for you animators out there because we work inside of an item-based animation system. We're only ever going to be animating an item, the topmost element inside of our hierarchy. We're never going to be going in and physically animating the transmission of our car, for example. We're only going to be animating the car, the topmost level of our hierarchy. Now, we can select items as I have here, but there are also a number of subcomponents that we can work at as well. Now, for this class, you're not going to be working inside, you're not going to be working inside of this component level very often, okay? If you take my 3D modeling class, you almost exclusively work with inside this component level of our hierarchy. But let's define, since this is kind of day one here in 3D, the basic building blocks of all 3D models. And in turn, I guess indirectly, the basic building blocks of all animations, computer animations. What is the lowest member of our hierarchy? The serf, if you will, of the 3D world. It's on the list, but it's not the lowest level. Whoever said it, you're absolutely right. Vertex. Yep, you got it. The vertex. What in the world is a vertex? Just a dot. It's just a point in space, right? By itself, it's kind of almost meaningless. Well, for the time being, it will be meaningless. When there it is, just a little dot, right? Now, the computer's tracking that dot. It understands where that dot is. It does have meaning inside of our world, but by itself, at this level of your education, there's not a whole lot we can do with it. When you get to GCOM 410, for example, we're going to be taking advantage of these vertices and looking at how we can plug them into a particle system, or using them to do massive duplication with something called a replicator. It's a pretty neat system. But for now, they really don't do much, right? Now, when we add another dot into the scene, and we connect the dots, we create our next component piece, which is called a line. Yeah, in the geometry world, it's called a line. Here in the 3D world, we call it an edge. Yep, you guys got it. An edge. Okay, an edge is just two dots connected to each other. We really don't want to have edges by themselves inside of our 3D scene, but an edge leads us to our last component piece, which is a polygon. Okay, poly meaning many-sided. Okay, and a gon is going to be a surface. Okay, now we have basically three types of surfaces that we're going to be working with. Okay, the lowest level is going to be this guy, because one dot by itself is a vertex. You add in another one, you get an edge. You add in a third one, and you get the next one, which is called what? A triangle. Okay, it is technically a polygon, but it's the lowest level of the triangle category. Okay. Now that's a three-sided surface. If we add four verts into the shuffle here, what do we get? Yeah. It can be a square, but it doesn't necessarily have to be a square. It's really a surface that has four vertices, okay? And this is called a quad for four, polygon, okay? Now, quad polygons are the gold standard. This is what we want to strive to build when it comes to 3D models. This is it, okay? This is the most extensible, flexible, usable surface type in our world, okay? In some rendering applications, like a game engine, they only render triangles, right? We still want to build with quads. Triangles are very hard to model with. They're very finicky, it's tough to deal with, really tough to edit. We kind of don't want to work with triangles as much as we can. Quad polygons, on the other hand, are very easy to make, very easy to control and build and edit. And what makes them the most powerful surface type in our arsenal is that I can instantly change a quad polygon into two triangles by doing what? Slicing it where? Yeah, diagonally, right? If I slice it diagonally like that, now I have a triangle here and a triangle there. Okay. Quad polygons also give us the ability to send our models and animations over into other applications that will continue to build upon them. Okay. A great example of this in the 3D modeling world would be a sculpting application like ZBrush. Okay. It only deals with quads. If you send it triangles, it goes, and you get weird pinches, and things start to fall apart pretty quickly. Okay? Quad polygons are the way of the future. They're pretty fantastic. Okay? We love them. They're not the last surface type. So we get 3, we get 4, and then finally, if we have a surface that has more than 4, I'll just do it simply like this. This is called an n-gon. If you go back to your algebra class, this lowercase italic n meant something. What does that mean? Does anyone remember? Yeah, it can be anything. It's almost like a container in which you can put any value into, right? Many things. In our world, an n-gon is a surface that has more than 4 verts associated with it. We don't like these. We can build them. Some applications support n-gons, others don't. Okay. Often we use an n-gon to really quickly block out the shape of something, with the idea that we'll go in after the fact and edit and slice and update that n-gon into something that's into a quad polygon mesh. Okay. Okay, so inside of Modo, we can work at any point inside this hierarchy. Now the defaults, and this is how we change which element to play within, is found at the top of our screen. And these are called selection states, okay, or selection sets based on who you talk to, okay? And these allow us to select very specific components inside of Modo. We can't select everything. It's only ever going to allow us to select what our selection state has been turned on to. So right now, just based off the feedback that the interface has given us, which selection state am I currently working at? Items. How do you know that? Item is highlighted. Get used to seeing that color. Orange is the selection color for Modo, okay? You're going to see it all over the place, okay? So right now, I'm only, able to select my item. At the item level, it's like selecting the entire car, right? I've selected every single part and piece of my model. Things are looking pretty great here. Love it, okay? However, maybe I want to go in and just select a couple verts, or maybe an edge, or move a polygon around. To do that, I'm going to have to change my selection state. And let's just do it real fast. If we return to the top of the screen here, we can very easily change our selection state just by clicking on any one of those buttons up there, okay? So we have vertices, edges, polygons. We're going to skip materials for the time being, and then items is this one as well. So let's just go in and select some verts. Now, I've selected my verts, or I've changed my selection state to verts. This is something for you veterans of working inside of 3D, okay? In 10.2, Modo 10.2, they've changed the way the vertex visibility behaves. And let me show you how to change this. It's actually a really neat thing. I like this very much, okay? It's a viewport property now. If you want to see your vertexes on your model, as I have here, hit the O key to bring open your viewport properties. And specifically, we're going to go into this active meshes section. And then down here in the display area of our viewport properties, we have this row that says show vertices. And now we have some choices as to when those vertices are going to become visible. We have always, which I'm not sure why I'd want to have it always on, but it's always on. In component modes, and this is kind of neat, this is where it starts to change, right? So if you're in the vertices, edges, or polygonal selection state, your vertex are going to be shown, right? Or, and this is what I have it kind of pinned to, only in vertex mode. Only show me my verts when I'm in the vertex selection mode, and I like that. That's pretty neat. I'll let you figure out how you want to work with it on your screen, but this is how I'm working with it on mine. All right. FYI, and here's kind of a cool little Modo trick, okay? These little forms are pretty neat. Has anyone discovered how to dismiss the form, how to kill the form? How do I get rid of my viewport properties here? Just click off of it, right? Just click off of it. Just click in the background, and the form will be dismissed. Whoop, there it goes, okay? Here's what I don't want you to do. I don't want you to hit the little dot in the upper right-hand corner, okay? This is not the close button, as you would see or would expect if you're working inside of like a Windows machine, okay? That little button there pins. It pins the form to your interface. Check it out. Previously, to dismiss the form, I just click in the background or click anywhere off of the form, and it would be dismissed. However, if I pin the form, check it out. I'm clicking off the form, and it's not going anywhere, okay? So that little dot in the upper right-hand corner is not the close button, okay? Because here's what people will discover once they start playing with it. If you click it again, it goes away, okay? So this pins the form. It doesn't close it, okay? To dismiss it, just click in the background. All right. Okay, so back to working with our selections. So selecting things inside of Modo is really easy. Of course, we have to change the selection state to select the component that we want to work with. For this next bit, I'm just going to change my selection state back over to polygons just to make it really easy for you guys to see what I'm about to do. All right? Now I'm selecting polygons, and you can see that as I roll over my mesh here, Modo is giving me this really lovely kind of rollover highlight color, telling me that if I was to left click right now, this would be the polygon that I would select, okay? So we can go in and we can select some polygons. Modo also has a really great paint selection mode. So if we were to left click and drag Any polygon or component that would show up underneath our cursor will also be selected as I left click and drag on the mesh. Perhaps, though, I want to add some additional components, some additional polygons into the mix here. How do I add components to an existing selection? I want to add that second row, and clearly my hands are not on the mouse right now, so I need to do something. How do I add more components to an existing selection? Shift, yeah, just like Photoshop would, okay? So if we hold down the Shift key, Shift, now we can add, right? That does something different, okay? So now with the Shift key in tow here, I can add as many of these as I want. Let's do the opposite. What if I made a mistake and I don't want to select all of them and I need to get rid of, I don't know, a couple in the center? How do I subtract a component from an existing selection? If you have some experience in Photoshop, be inspired by that selection system. Whoever said it, you're absolutely right. The Control key. Yep, absolutely. So if you hold down the Control key and then click on an existing selected component, we can remove it from that selection, which is pretty neat. Okay? Now, from time to time, we're going to want to completely subtract or drop the selection for everything that we have selected, right? How do I completely remove the selection from my model? Yeah, you got it. Just click in the background of your scene, basically off the model. So if I go back over into my viewport here and click on the gradient in the background, you can see that all those polygons have been removed. Okay. From time to time, you're going to want to select big swaths of things, whether it be polygons or edges or even items here in the not-too-distant future. And individually selecting and clicking on things may not be something that you want to do. So let me show you a really great alternative to our selection system that will speed up selecting big groups of components inside the scene itself. And believe it or not, it's the right mouse button. So if you right mouse button and drag, you'll get this little squiggly line, or it may be a box on your screen. But whatever shows up on the inside of that selection, that lasso selection as it's called, is going to be selected. Now, I hate with a passion that lasso selection type. This squiggly line just does not make sense for my brain. I know why it's there. It's so you can go in and select like very specific things, right? But it just doesn't work for me, and I don't like it, and I don't like to use it at all. So if you're like me and you want to change it, check it out. If you go to the top of the screen under the Select pull-down menu, there's an option down at the bottom of this menu that allows us to change our lasso selection style. And I like rectangle. It just works for me. I think it's because I'm an old-school Photoshop user. The rectangle selection system just works for my brain. Okay? Find one that works for you. I really don't care. What makes sense to you makes sense to you. And now, if I right-click and drag, you can see I get a nice little selection box. Okay? Now, if I select everything in the model, look carefully at my screen or at yours. Have I actually selected everything on the model? No. Look carefully at it, okay? And you can see pretty quickly that there are a whole series of polygons that weren't selected. Check it out. Look at all this stuff on the top that wasn't selected, and boom, look at the back isn't selected at all. What is going on? The right selection button, okay, the right button, is only going to select the polygons that are facing the user, the front-facing polygons. The polygons whose surface normals are facing me, okay, as the operator of the machine. So all the polygons on the back of the model that are facing in an opposite direction are not going to be selected, and the ones in the top are not going to be selected. So how in the world do we select the entire mesh quickly? Is there a way that we can select everything in the box? Yes. What is it? The middle mouse button. You're absolutely right. Check it out. The middle mouse button is going to allow you to select through, as it's called. So now I'm holding down the middle mouse button and dragging out a box. Bloop. And there she blows. And I've selected everything inside of my little teapot, which is pretty neat. So the right mouse button is only going to select the front-facing polygons. Boop. However, the middle mouse button is going to select through, and it's going to grab everything. Now I've grabbed every single component piece that was inside that box. Cool, huh? All right. Now, Christine pointed out something that I thought was pretty fantastic. If you double-click on certain pieces, you'll select the contiguous polygonal islands. If you look carefully here, my teapot is actually broken into 3 different pieces. You have the handle, and I'm just double-clicking on the polygons here, the base, and of course the spout as well. Yeah, it's 3 different pieces. In addition, you can also pair the Shift keyboard modifier into the mix here. So if I hold down the Shift key and double-click, it grabs the entirety, or it adds the entirety of the base to it, as well as the handle. Bloop, we're on our way. Cool, huh? All right. So selecting things inside of Moto is really important. It's going to be one of those elements that we do all the time. It's kind of one of our bread and butter operations. It's something that we have to do in order to do our work. Okay. However, at the end of the day, we also need to do some transformations. We also need to move, rotate, and scale a number of items inside of our scene. Okay. Let's check it out real fast. I'm going to grab the spout of my teapot. And let's go over and start looking at the basic transformation tools. Move, rotate, and scale. This is the move tool. I'm in my basic collection of tools now. This is the move tool. This is rotate, and this is scale. Let's fire off the move tool real fast. And before I travel back over into my viewport, I want you to look closely at the color of the tool. Okay? What's changed about the background color of that tool? It's highlighted. Remember this, right? Whenever we select something, it goes orange. And whenever we activate a tool, it goes orange. Okay? This is an important distinction inside of the Moto tool pipeline. Okay? Because whenever a tool is orange like this, that means it's on, active, and influencing our scene. We have to manage this. Okay? Inside of the 3D world as a whole, you're going to have to be disciplined with how you use tools. And this is probably the biggest kind of pitfall that you guys are going to fall into, is that you'll leave your tools on by accident, and then that tool will accidentally continue to influence your scene. Okay? So think of it like driving a car, right? You jump in your car before you come to class today, or jump on a bus, whatever, right? And you jump in, you put your key in the ignition. Well, before you do that, your seatbelt on, right? Safety first. Turn the key on, right? You turn your tool on, your car, right? Then you drive to school, you park, then you turn your car off, okay? We're going to be doing the exact same thing. We turn our tools on, we use them, then we turn them off, okay? When the icon's orange, it means it's on. And if you look very carefully inside of our viewport, we get these lovely translation handles that will allow us to change the position of our spout any way that we want. Here's my suggestion to you: be disciplined. Only grab the arrows, okay? Don't grab the center. This is dangerous. This is so dangerous. Don't do this. Because what axes, along which direction are you moving this spout? I don't know. I don't know. All of them at the same time, okay? We need to be control freaks, okay? We need to edit, move, rotate, and scale with precision. Because we need to know exactly which direction we're moving our objects, how we're rotating them, and then the size of them as well. So be control freaks. Get a little OCD on this, okay? All right, so grab the handles, and don't click until you see it go yellow. That way you're clicking with confidence. All right, so that's the move tool. Oops. Now I'm done working with the tool, right? Let's say I just move my spout, I don't know, way over here. I'm done with it. Now I need to turn the tool off. How do I do that? Yeah, so there's actually 4 different ways you can deactivate a tool. And let's just go through it real fast. First and foremost, the easiest way to deactivate a tool, believe it or not, is just go up there and hit the button again, right? Hitting the button again will turn the tool off. Let me show you. Bloop. There it goes. Now it's off. Once you see the background color return to its normal gray, the tool handles will disappear. That's a good indication that this tool is no longer influencing our scene. What's another way that we can turn off a tool? All right, what was the one that everyone just kind of jumped to? The space bar. If you tap the space bar, it's going to turn that tool off, which is kind of nice. You'll see me doing that often, just tapping the space bar. If you remember, I encouraged you to put your index finger right there on the Option key on your keyboard, which allows you to put your thumb bloop, right down the space bar. We're going to be using that space bar a lot. All right, what's another way that we can turn a tool on? You got it. I like it, Ray. That's a great alternative. So if you think about it, the keyboard shortcut for this tool is the W key, okay? If you hit the W key one more time, it goes away. Here's another one. So many ways to turn a tool off, okay? Hit the Escape key, turn the tool off, okay? Also, and this is one that I do quite frequently, is the Q key. Q is in Quebec, okay? The Q key kind of technically activates the selection tool, okay? It's a nice handy-dandy way of going in and deactivating a tool, okay? So there's 4 ways of very quickly going in and turning off a tool. Get used to this. We turn a tool on, we use it, we turn it off. All right. With my spout still selected here, let's just look at the rotation tool. Now, the rotation tool, you also have to be very, very disciplined in. Only grab the rings. Don't grab the center, because I don't know how much I just rotated that thing or at what angles. I've lost all control over my transformation. So make sure you go in and just very, very specifically grab the rings. Okay. If you look very carefully, down here inside of our tool options, we also get some channel boxes that we can transform and rotate our objects along very specific degrees. So there is some precision here that we can gain quickly by leveraging the power of our tool options. And then lastly, let's drop this tool real fast and go back in time a couple steps. The Scale tool. Okay. The Scale tool can be found right there inside of our system. The Scale tool, as one might imagine, allows us to make our objects bigger or smaller. Of course, naturally, we can disproportionately scale our objects along a specific axis. I can make it a little tall, or I can go in and make my spout really big if I wanted to. Okay. However, what's the magic that allows us to uniformly scale this object along all 3 axes simultaneously? Yeah, that middle. Okay, that middle blue circle, and let me zoom in so you guys can see it. That middle blue circle is going to uniformly scale this object along all 3 axes simultaneously. It's a kind of a great way to globally make it bigger or globally make it smaller. Okay, so that's the Scale tool. I want to hit the space bar to drop the tool and continue on our way. If you go back over here into our toolbar, you can see that those transformation tools have been stacked right next to each other. Move, rotate, and scale. This one's the item transform tool, which we'll talk to here in a minute. We'll come back to this one. But if you really take a look at it, the Move tool's keyboard shortcut is W. What's the keyboard shortcut for rotate? E, and then lastly, scale is R. If you look down at your keyboard, W, E, and R are all ganged right next to each other, right? In addition, the Q key is on that same row of your keyboard. This is intelligently designed. Our hand is naturally going to be kind of staying on that side of the keyboard to make sure we can get access to all those really important keys. One more thing, and then we'll take a small little break because I know I've been going for a little bit here. Is remember our little Moto selection mantra. Now I'm going to go in and, I don't know, just move some of these parts and pieces away from each other to illustrate the next idea. At the component level, at the polygonal level, I've moved parts of my model away from each other, right? Naturally, selecting each individual part will give me direct control on that selected object, right? I can rotate it, rock and roll. However, if nothing is selected and I fired off the rotation tool, what would you expect is going to happen? everything is going to be rotated. Remember that. It's an important foundation level idea of working inside of Modo. Whatever is selected will be edited. If nothing is selected, as it is here, everything is going to be edited. Okay? So I don't have a single thing selected here. With my rotation tool on, let's just do it real fast. Let's grab the green guy. Woo! Check it out. Now, every little piece of my model is being rotated and influenced simultaneously. Pretty cool, huh? Questions? Questions on what we've talked about so far? All right, great. I tell you what, I've been yakking for, well over an hour and a half by now. So let's just take a small little 5-minute break. Sound good? Okay, get up, stretch your legs, we'll come back, we'll have a break. Okay, so before we left for our little break, we were talking about how to work with selections inside of Modo. But this is an animation class, right? We need to really start looking at how to animate inside of Modo. The animation inside of Modo is pretty fantastic, and I want to spend the rest of our time together today talking about this animation engine, okay? As I mentioned at the beginning of class today, Modo is an item-based animation engine, so let's just take a look at that real fast, okay? Here's what I'm going to do. I think I'm just going to get rid of this mesh item. Bloop. Here we go. I'm going to click on it there. Oh, it says, are you sure you want to delete it? Yeah, I'm sure. And then I'm going to go back to my geometry pull-down menu at the top of the screen, and under unit primitives, in new mesh, I'll just add another teapot in, just so we have one that's already constructed, ready to rock and roll. Okay, so we're done. We're not going to go back to the modeling tab again today. The rest of our time is going to be spent in the animation layout. So if you haven't already, go ahead to your layout switcher at the top of the screen, just click on the animation tab, and welcome to our new animation home away from home. Once again, to maximize all the contents of my scene here, I'm going to hit the A key. Now the A key is going to show all of the different items that are currently influencing our three-dimensional scene. That includes the camera and the light too, which isn't why our scene has zeroed in on the geometry. There are many, many, many different types of items inside of Modo. Of course, we have mesh items, which are gigantic containers for polygons, edges, and vertices. We also have lights and cameras and dynamic items and particle generators and replicators. There are a laundry list, a very long laundry list of items that we can create and animate inside of Modo. Okay? So get used to working with items and working in your item selection state. Now, if you look very carefully at our interface here, that top row that we used to see in the modeling layout that allowed us to change our selection state is poof, gone, right? It's gone here in the animation world because they're making a big assumption that you understand the keyboard shortcuts that take us in and out of all these animation states, okay? Let me help you out. Let's just return real fast to the Model tab and memorize real fast the keyboard shortcuts that allow us to zip around our different animation states, okay? Because we're not going to have access to these over the animation layout. So right next to the selection state button, you have a little number there. That's the keyboard shortcut. So it's the top row on your keyboard. 1 is going to select vertices, 2 is edges, 3 is polygons, 4 is actually materials, which we don't need to deal with right now. And then most importantly for us in the animation pipeline is 5. That allows us to select items, okay? So remember those. Commit them to memory and put them down in your notes. 1 is vertices, 2 is edges, 3 is polygons, 4 materials, and most importantly for us in the animation workflow, 5 allows us to select an item. So if we return to our animation layout with that in tow, we can very quickly go in. Let's just do that. There we go. We can very quickly go in and let's see, I hit the 1 key on my keyboard and check it out. I can only select verts now, but I want to select items, so I'll hit the 5 key and I'll select my item. Okay? It's assumed that you have the basic command of the keyboard shortcuts for selecting the different selection states. Okay? Now, one other thing, the default shading parameter for your viewport in the animation layout is slightly different. Okay? Because if you look at how my teapot looks here versus how my teapot looks over here, what's the massive difference between these two different layouts? That one's pretty light, right? And if you look at the animation tab, that exact same teapot is being drawn differently. We're going to want to change this. We change the viewport shading model quite easily by going to the top left-hand portion of our layout, of our interface, right here. This changes the shading model for our layout. And right now, the option that we've chosen, or the computer has chosen for us, is the shaded shading model. But we have some other options in here that are pretty cool. If we want to see the wireframes, exclusively the wireframes of our stuff, there it is. We also have solid. I never use solid, by the way. Vertex map is really important. You'll see this in GCOM 410 a lot, so we'll come back and talk about that in another class. Then, of course, there's shaded texture, which is going to show any images that are currently mapped to our model. And then the one that I would encourage you to look at is default. Okay? Just leave it on default. You're ready to rock and roll. This is the best technology to use to view our scenes on these machines. Now, if you're working at home and you got like a $5,000 computer with like a $3,000 graphics card in it, okay, then I would encourage you to change your viewport to use the advanced. To use this one, to use the advanced viewport, okay? This one right here. This is some pretty bleeding edge technology. It's advanced for many, many different reasons. Unfortunately, it requires a pretty beefy graphics card to really take advantage of all of its power and features. Our little iMacs, we just don't have like a $3,000 graphics card inside these machines, so we're really not going to see a direct benefit from playing inside of the advanced viewport, but you're more than welcome to check it out. Watch what happens when I click on it. Wait for it, wait for it, wait for it. We're completely changing our viewport model at the moment, and there we go. Yeah, one of the cool things that we get with the advanced viewport is realistic shadows. Okay, if you look carefully here, you can actually see the shadows being cast from the directional light in the viewport itself. Something we get a small suggestion of inside the default viewport. We don't see the shadow popping down here at the top. So it really is a cool environment. The real-time shadows is one of about 24 different features that the advanced viewport brings to the party, all of which we can't support with the graphics cards that are on our machines. I mean, it really is. It's tied directly to your graphics card, okay? If you have like one of those really fancy those GeForce Titan X cards, right? Like literally they're like $2,000 for a graphics card, right? These iMacs don't even cost $2,000, right? Yeah, if you have one of those, or one of the Quattro effects cards that are like more than a car, then you can play in this world, okay? You're going to see me working in the default viewport for, I don't know, just about everything, okay? So keep that in mind going forward. Okay, so welcome to working inside of the inside of the animation layout. As animators, in every sense, we're going to be actors and filmmakers, choosing to create a performance or a movement that showcases a very specific thing. So they've given us this wonderful, this lovely wide perspective of our scene in the animation layout so that we can focus on our work. However, from time to time, we're going to need to get access to our item list or maybe one of our utility panels. So let's check out the bottom of our interface, because this is where we're going to find all of our animation tools and access to some of these really important item list and utility areas of our interface. Now, we're going to be talking a lot about this over the next 15 weeks. I'm not going to go over all these buttons and switches today. There are some good ones in here, and there are some ones that we're never really going to deal with, okay? But for the most part, I want to focus on the timeline. Because in the animation world, we're working now in a series of frames within a range of time. Our timeline down there at the bottom communicates to us quite directly the range of frames that we are available to work within. This isn't like Premiere Pro or like Final Cut Pro, where we have an infinite timeline. We actually define the range of frames that we want to work within. Okay? So it is very limited. However, we can easily change the length of our timeline, which is communicated down here at the bottom of our screen, with our timeline settings. Okay? So right now, and I apologize, it's kind of hard to see because it's small, our timeline goes from frame 0, and if you follow the ruler all the way down over here, how many frames are we able to animate within at the moment? 120. Okay? Maybe we want to extend this a little bit. Add some more frames for us to play on. The part of the interface that allows us to change the length of our timeline is down here under our timeline settings option. Okay? Let me zoom out of here a little bit and click on the button. Because there's some important elements in here that we want to change. Okay? First and foremost, we have two different time ranges that we get to edit. We have the scene length, so scene start and scene end, which represents the total animation timeline, right? And then we can, if we wanted to, we can only preview maybe just a little portion of that total length. So maybe we have 120 frames from scene start to end, but maybe we only want to look at the last 30, okay? So if we change the current start to 90, notice that the length of our animation doesn't change, okay? But now we're only looking at frames 90 through, over here on the right-hand side, 120. So there's two different values that we get to adjust here inside of our scene or our timeline settings. In addition, I want you to pay really close attention to this gray bar over here. What do you see numerically on this gray bar? There's 3 numbers. I'll zoom in so the folks in the back can see it. What do you see down there? There are 3 numbers. What do you see? 90, 30, and then 120. Okay? Take a guess as to what these values represent. Bingo. Excellent. Okay? It's the current start time, which is frame 90. The current end time, which is frame 120. And then the middle number is the duration of that range of frames, okay? Which is pretty cool. So I know just by looking at the middle here that I'm looking at 30 animation frames, okay? One of the cool things about working inside of Modo is that this current start and end value is interactive. We can change it at any moment just by grabbing on the end of our gray bar. See how there's a little dark line here? That makes this portion of our gray bar into a button. And I can interactively extend my current start and end value just by left-clicking on that gray bar. Now I'm previewing frames 38 all the way through to 120. Okay, so if I can grab this side and drag it down, and now I'm previewing from 38 all the way to 87, and I'm looking at 49 frames of animation. Okay, if I hit the play button, you can see that my current time indicator, my playhead, which is that little white line, is only going to preview and showcase the animation within the current start and end range of frames. So it's something to look at. It's an important value. It allows us to focus our timeline on one portion so that we can edit and animate and create within a small portion instead of being forced to look at everything. All right, let's go back for a second here. I'm just going to return this to the end. So I'm looking at 120 frames, the entirety of my animation. And let's go back into my timeline settings, because there's a couple other things in here that I want you to look at and understand its role, okay? So current scene start and scene end. I forgot to mention this before. I almost always put 1. Okay, I know it's kind of silly, but in my world, there is no frame 0. Right? The first frame of animation is frame 1. Okay? The first frame of animation is not frame 0. That doesn't make any sense, right? Frame 1 is the first frame, right? It makes it really easy to communicate with a large team, right? Because when you imagine that you're looking at dailies with your animation crew, and the director comes to you and says, "Hey Pat, I want you to change the first frame of the animation." Well, if your frame timeline starts at frame 0, is he talking about frame 0 or is he talking about frame 1? Confusion immediately, right? Change your scene start to be frame 1. It's really helpful, like extraordinarily helpful. And it also makes working over in After Effects a whole lot easier too, because we're going to be rendering our image sequences here in After Effects. After Effects, guess what frame After Effects starts on? That's right, frame 1. Okay, so it's important that both applications kind of sync up so that we're working together kind of quite beautifully here. Okay. If we keep going down, make sure that play in real time is checked on. That way, the timeline is going to play back our animation at the frame rate that we've established before, which is 24 frames a second, which matches the frame rate of the cinema world. Okay? If you have play real time turned off, the computer is going to try to play back your animation as fast as it can. So you're going to get a false read as to how fast or slow the movements of your animation really are. Okay? Keep it on. It should always be on, in my opinion. We also have a value here which will tell the playhead, or tell what the playhead to do. It's just going to repeat the animation once it gets to the end. You can stop it. I'm not sure what the difference between repeat and wrap is, but I don't think I've ever turned it off of repeat, by the way. So it just keeps looping the animation. Oh, wrap may be like a ping pong. Let's find out. I'm curious now. So we'll go from 0 or 1 to 120, and then go from 120 back to 1. Let's find out. Watch the little white line. Here it goes. What happens when it gets to the end? Bloop. Oh, it goes back to the first frame of the animation and stops, which is different from hold. If we do hold, once it gets to 120, it's going to stop on frame 120. Yeah, okay. I want to put the end behavior back to repeat. And let's just look at this real fast. The next two things are things you really shouldn't ever have to change, but you can change them. It's the time format. This is how all the ruler numbers on your timeline are displayed to you. At frames, it's just whole integers, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so on and so forth, right? However, if you're working in the television world, or if you're integrating your animation into a professional video timeline that you'd see in After Effects or Premiere Pro, they work in a SMPTE timecode world, or they could work in the SMPTE timecode world, or in a film code, which is film feet, okay? Point being is that we can change the markers in our timeline to use whatever timecode system that we are working within. For us in here, we're going to leave it at frames for 100% of the time, okay? I do some broadcast work from time to time, and whenever I do that, I always change it over to SMPTE timecode, so everything works and syncs up quite beautifully with how my brain is working over in Final Cut Pro. And then last but not least, and I apologize for zooming out, the frame rate. We have a number of different frame rates here. Film is 24 frames a second. We're going to be working at this frame rate for the entirety of our animation time together this semester, so we're not going to change it. However, if you are choosing to work for a professional broadcast company, you can change your frame rate to work inside the television industry quite easily just by going to NTSC 2997. Or if you're pretty much anywhere else on the face of the planet, the television frame rate is 25. Good old America, we just got to do things our own way, right? We work at 2997 and everywhere else works at 25, which is kind of fun. Or you can do your own custom frame rate too. And this is actually kind of nice if you're doing something for the web. Oftentimes web animations are of much lower frame rate, so we can animate to that frame rate by choosing a custom frame rate in our timeline settings. Or if you want to animate to like 60, which I don't know why you do, but you can do that. All right. Questions on how to work with our timeline. All right, rock and roll. Let's get to animating here, okay? Animating in Modo is really, really easy, and as I mentioned before, we are an item-based animation engine. We're never, ever, under no circumstances, at no point in the next 15 weeks, ever going to be selecting a polygon and then animating that polygon. We're only ever going to animate an item. It's not because I don't want to animate polygons, it's just because our animation system is an item-based animation system, okay? So we're always going to be animating the totality of the car, never a portion of the car. So I can't at the moment go in and animate just the spout moving independently from the teapot. I'm only allowed to animate the entirety of the teapot, okay? If I wanted the spout to animate separately from the teapot, I'd need to put it in its own item, okay? So let's get into work here and start working and animating inside of Modo. It's pretty easy. As with everything inside of Modo, it begins and ends with a selection. This is more important, or just as important, inside the animation world, because at the item level, we're going to be asking the computer to look at the item transform channels, its global understanding of its position, its scale, and its rotation. These are values and chunks of info that we often find inside of the item list and its properties tab. So if you're used to looking for that info in that area, click on this button right here. This button will pop in your item list and properties tab. Boop, there it is. So here's your item list and your corresponding property tab. in every sense, what we're going to be animating at the item level are these channels, the position, rotation, and scale of an object. Think about that for a second. Let that sink in. Pretty much all we're ever going to be doing is rotating the position, the rotation, and the scale of an item inside of our scene. Even for characters, okay? Now, there's going to be a lot of items on a character that we're going to be animating. For example, if we wanted to bend our arm like this, we're going to be rotating the elbow joint, okay? But we're going to be animating the rotation of that item, okay? So how do we animate? Well, the first thing that we have to do inside of Modo is make some pretty meaningful selections with the channels that we want to animate. We don't want to animate every single position, rotation, and scale channels. We want to get real specific. For me, I think I'm going to build, and I would encourage you to do the same, I'm going to build the silliest animation on the face of the planet. I'm going to move my teapot from the left side to the right side. It's going to be the best animation ever, right? Let's just do it real fast. So the first thing that we have to do is tell the computer what to animate. Now, these are channels within an item. So if I want to animate my object going from the left side of the screen to the right side of the screen, which of these channels should I look to animate? Position. You got it. Position. And maybe just position along the x-axis, but we'll do all three at the moment just to make life easy. But remember, we're animating channels within an item, okay? So we're going to animate the position channels of my little teapot here real fast. And to do so, it's pretty easy, okay? The first thing that we have to do is select and kind of focus the animation engine on just the channels that we want to animate. Now, does anyone know how we can focus the animation engine on the channels we want to animate? That does something different, but you're in the ballpark. That does something different, but we're in the ballpark. Yeah, that kind of works. Now, if you look very carefully here, as my mouse rolls over each one of these channels, you can see the background color of that row change. It's actually a selection state, okay? Or it's like a selection rollover highlight. If I click on this right here, watch the background color of this square and dot. What color does it go? Yeah, that orangey yellow, right? That iconic selection color for us in Modo. If I hold down the Shift key, I can even grab all of those channels, right? So we have to select the channels first. Once we select the channel, we get to keyframe them. Now, who knows what a keyframe is? Yeah, you probably have heard the term if you've been hanging out in the animation world for a while. If you go all the way back to the early days of the animation industry at the turn of the century, a keyframe was a drawing, right? It was a master drawing, a storytelling pose, if you will, that represented a key moment in a very large sequence. Think about it through the lens of like a comic book, for example, right? A comic book panel has, Batman in a very specific pose, right? That's a storytelling pose, a key part of the sequence that establishes an emotion, a narrative, or a movement of that character, right? A key frame, a storytelling frame. Now, we need to tell the computer that these values, that the current position of our teapot is a key frame, right? A storytelling, crucial moment for our animation. Now, there's a number of different ways that we can generate a keyframe in the system itself. Let me introduce a couple ways for you real fast. The easiest way is to go to these little dots and just click on them, like that. Those little dots create a keyframe. So if we see a red, if those little radio buttons are filled in with red, we've just captured that value and stored it into a keyframe. And I like to use that idea as something that just kind of works for me. I've just captured some information, okay? I've grabbed that data, and I've put it in one of those awesome little plastic eggs you get at Easter, right? Okay? We just captured it. That's all we've done. And we've told the computer that that this channel needs to be at these values at frame 1 of our animation. If we go down here into our timeline, you can see the computer has given us this little long white rectangle. That's its visualization of a keyframe. Okay? Now, it's not telling us what is keyframed, but it's telling us that there is a keyframe on this frame of our animation. All right, so once we've keyframed the first storytelling moment, if you will, the start of our animation, we need to start going through the rest of our animation kind of sequence. So here's the process that we're going to go through, okay, on every single animation. This is the basic animation sequence. We're going to define with the current playhead indicator, so that white line in our timeline, the first frame or when we want our animation to begin. And you can change it just by left-clicking and dragging it. I want my animation to begin on frame 1. Bloop. So I'm going to park my playhead on frame 1. That's step 1. We already had done that. Okay. Step 2 we just completed, which is keyframe the channels that we want to animate. And for us, we're keyframing the position channels. Okay. Which we've done. Okay. Mission accomplished. Good job. All right. Step 3. Now, this is the step that almost everyone misses the first or second time out. Step 3 is to physically move your playhead forward in time. Okay? And I'm going to just send mine over here to frame 24. So I've selected frame 24 on my timeline. So we have to physically change the time, the playhead's location in our timeline. Once we've changed the playhead's location to a future time, then, and only then, can we move our little teapot. So I'm just going to fire off the move tool. I'm going to move it right there. Okay? If you look down in our timeline once again, a keyframe has been added on frame 24. Pop quiz, what's the visualization of a keyframe? That little white bar, okay? That is a keyframe. If you're coming from the Adobe world, you're probably used to seeing diamonds everywhere for keyframes. For us in the 3D world, and it honestly does not matter if you're working in Maya, Moto, Cinema 4D, Houdini, they're almost always bars, white bars or colored bars, okay? The crew down at the Foundry have done us a solid, and they've given us a nice representation of the relationship between these keyframes by drawing that little green line. All right. Let's play my animation. I'm going to do this. I'm going to change my start time or my end time to frame 30 just so I don't have to look at 120 frames of animation. And I'm going to hit the play button. There it goes. Ha! Mission accomplished. Our first animation. Wonderful. Great job. You did it. Give me the Academy Award right now. Can everyone do this? I don't want you to leave today without making something move. The only way to learn animation is to get your hands dirty. Hit the keyframes, okay? Crowdsource your problems, okay? If you have a question and I'm not available to answer at the moment, ask your neighbor, they can help. But everyone gets something to move inside of your computer. Were you able to get it to work? Yeah. Okay, great. Awesome. Ray up and running? Yeah. All right. Do yourself a favor. Turn these buttons off. Yeah. There you go. That will help. We're going to get to those in a minute. Well, in a couple weeks. But just until then. Great job. Great job. Mm-hmm. Were you able to get some animation, Claudia? Yeah, okay, great. Yeah. Put it on a loop. What do you mean? Like repeating over and over and over again? Is that what you mean? Yeah. Everyone able to get something to move? Miss Hoover, you doing good? Yep. Looks Andy, you got it? Yeah? Did you get some animation?
Not yet.
Not yet. Okay. Yeah, there we go. Now, where's your time? Okay, check it out. Your playhead is way over there on 0. Put it on frame 1. There you go. Now, keyframe it in. Okay. What's next? No. Yeah. Move your playhead.
I almost did the
Good.
old mistake.
Yep. There it is. Good job. Zach, you up and running? Yep, we're good. Yeah, okay, so when you changed your sequence settings, which is good, your playhead stayed over here on frame 0. Go ahead and just click it on frame 1. There it is, okay? Now go ahead and lock in that value. Keyframe it. Awesome. What's next?
Drag.
No, don't drag that. Drag the playhead, the white line down here. Yep, because now we're advancing time. Just click on like 35. It'll go wherever you click. There you go. Sometimes when it's on frame 1, it's kind of tricky to grab. When it's on a future frame, then you can left click and drag it anywhere you want. Okay, what's next now? You don't have to create if you just move your teapot, a keyframe will automatically. There you go. Good job. That's it.
And then just play.
Just play your animation, see what you get. What you got?
This is what I did.
That works. That works. Good job. Great job. All right. Other questions? Did everyone at least get something to move? Yep. Rock and roll. I know it's not a great movement, but for day 1, it just gets it is what it is for day 1. Okay. Let's go ahead and stop this a little bit and start looking at a couple things. Okay. Because adding keyframes is one thing, but often we're going to need to go in and continue to edit keyframes or maybe change their location on the timeline. Okay. And that timeline is part of our workflow. It's a tool that we can use to continue to refine our animations that we build. Okay. Now, right now, I'm currently looking at the first 30 frames of my animation. However, if I return to my current start and end timeline indicator, this little bar, and drag the end way over here to the right, whoop, now I can see all 120 frames. Maybe I want my little teapot, the movement of my teapot, to go 120 frames. How can I change the location of an existing keyframe? Do I need to start over to make it longer? No, I just need to move the keyframe in my timeline. Okay? Let me stop my animation here real fast and check it out. These little white bars are editable. You're actually seeing the first row of another window that we'll get more comfortable with in the near term, called the dope sheet. Okay, more on that much later. Okay, yeah, I don't know why it's called the dope sheet. It is what it is. Okay, these white bars are things that we can left click and drag on. So check it out. I'm going to grab that little white bar, and if I drag it to the right, check it out. I'm now moving that keyframe's position over here to frame 120. If I was to play my animation now it's doing the exact same movement. It's just taking 120 frames to go from its start to stop versus 30 frames. To make an object move slower, we need to space the keyframes out, physically, move them away from each other. The computer now requires 120 frames to do the exact same movement versus what we had a minute ago, which was 30 frames. It's still going to the exact same start and the exact same end, just taking longer to do that. Okay? What if we wanted to, I'm just going to stop my animation and put it on frame 1. What if my animation director comes in and says, Pat, this is okay, but I'd really much rather have your teapot go a much larger distance inside of our scene, right? And I go, okay. And he says, I want it to start way over here and then end way over here. Now, I'm not editing the position of a keyframe. I need to really go in and edit the values that are connected to that keyframe. Has anyone stumbled on this? How do we edit the current values preserved in a keyframe?
Just get to the frame where the keyframe ends and
I like it. So let's stop right there. Okay, so the first thing that we need to do is we need to move our playhead to the location of an existing keyframe. Okay, so let's, if you take a look at my timeline here, let's pretend that my playhead is here on frame 57. I need to get it from 57 all the way to the current location of this keyframe, which is frame 1. So I'm just going to move it over. When my playhead is docked on this frame of our animation, any change that I make over here in our properties panel will be preserved inside of that keyframe. Okay? So that's how we go in and we edit the values that are currently saved in a keyframe. We move the playhead to its location, and we make the change. So I'm just going to fire off the move tool. I'm going to move this thing way back over here. And now it's going to start here and travel to that same spot. Okay? So let's do it one more time. I want to change. Let's look at the ending pose, if you will, for my animation. It's right there. Maybe I want the ending pose to be way out over here. How do I do that? Walk me through the steps of editing the values of a current or existing keyframe on my teapot. We just did it. Let's do it one more time. So the first thing that we have to do is move the playhead to the location of the keyframe that we want to change. Okay? I want to change the keyframe that's way out over here, so I want to move my playhead to that location. Okay? With the playhead at the same location of the keyframe, I can make a change, and the computer will automatically update that keyframe and preserve that change. If you look at my animation now it goes from the far left all the way over to the far right. Okay? Now, working with keyframes and this auto-keying system inside of Modo is really kind of fun. It allows us to fluidly animate and organically make changes to our timeline. But we got to be mindful of the location of that playhead. The playhead is a tool inside of our animation pipeline. So we can't forget about its role and function. Let me show you a pitfall that people often fall into. Let's pretend that I stop the animation right here at frame 160 in the middle of a timeline. And I say to myself, I really want to change something here, okay? But I don't change the location of my playhead. Maybe, conceptually, the art director comes in and says, Pat, I want the start to be like over here, okay? If I don't change the location of my playhead back to that first frame and then make a new change, what happens? It makes a new keyframe, okay? Check it out. It makes a new keyframe for me. And now, my animation's way up there. Starts there, goes up the top, and then it ends over there. So we got to be careful. We got to be careful. Now, it starts kind of down here at the bottom, and then in the middle on frame 60, it goes up to the top. But why doesn't it return to the bottom on frame 120? Interesting puzzle, right? Let's analyze and investigate specifically what's been keyed. Those red dots on the channels do a really great job of communicating to us exactly what we saved. So I'm on frame 1. I've moved my playhead back to frame 1. And if I look over here in my properties panel, I can see exactly which channels have been preserved, which values we've captured. Now, help me out here. Which values have I captured, or which channels have I captured with a keyframe? Position X, Y, and Z, right? Position X, Y, and Z. If I go to the next keyframe, now I want you to pay real close attention to which channels have red dots in them, to which channels have keyframes. Let's go to the next keyframe. And here's a great little trick. These buttons in here, this will advance your playhead to the next keyframe. This is the previous keyframe. This is the first keyframe. This is the last keyframe. Good little trick. Okay, so here I am on frame 60. Once again, what in the world is going on over there? Which values have been saved and preserved in this keyframe? Only position X, because that's the only one that's got the red dot. The other two are green. When the other two are green, or when the dots are green, that means a separate keyframe. A different keyframe is currently influencing those channels. Okay? So on the first keyframe, we animated and keyed position X, Y, and Z. The second keyframe, we only keyed in position X. And if we once again travel over to our last keyframe, what's been keyed over here? Just position Z, okay? We didn't change or key in its location inside of our three-dimensional scene along the x-axis, which is why it's still at the top of the scene. Okay? It's taking all of its x position information from keyframe number 2. Okay? So let me do this, and this is kind of cool. Maybe I want to have the location along the x-axis be the same at the beginning and at the end. Well, I'm just going to go and copy some values. So it's 0 meters. I think I can remember that. Just copy that number. And if I go to my last keyframe, I'll paste that value in, and it will automatically key it for me, which is nice. And now I'm going to get the animation that I want. It's going to go up, and then it's going to come back down, nice and slowly. Point being is that we need to watch very carefully which channels are being keyed for us automatically. Okay? We're in the driver's seat behind this. Okay. This definitely gets filed into only you can prevent forest fires. Okay? You're the operator of this machine. You need to pay attention to specifically what channels inside of our item are being animated and when. One of the great things about working inside of the Moto animation system is that we can key multiple channels simultaneously. So we're not limited to just working individual or on individual transformation channels. So maybe I want to have my teapot spin as it goes along its hierarchy, or excuse me, along its animation. So earlier we were working with the position values. Now I want to work with the rotation values, and I want to show you a different way to key in this information, because we don't necessarily have to go into the properties panel. Believe it or not, that's what this part of our animation layout is reserved for. If you look at it, this is the properties panel just kind of laid out slightly differently. The first row are all the position values. The second row, these are all the rotation channels. And the third row naturally is going to be all the scale channels. Okay? If you also look, if you need some help, need some continued kind of understanding of what's going on here, this is the move, rotation, and scale tools right there. You can even click on them, move, rotate, scale. That just activates the tool. It doesn't key anything. However, if you wanted to go in and lock in some keyframe values for specific channels, you can do so quite easily, either just by going in and clicking on the dot, okay, which will key in and preserve that value on frame 1. Or, check this out. I want to hit undo. Let's just turn it off, by the way. And that's how you get rid of a key. You turn it on, and then you delete it by hitting it again. If you want to key all the rotation channels on this item, that's what this button does. And now check it out. Whoop. All 3 get rotation keyframes. Okay? Let's go to the last frame of my animation, and I'm going to change it to 360 degrees. If we play my animation, now my teapot is going to move and rotate simultaneously. That's pretty cool, huh? So we can animate multiple channels inside of our transform area at the exact same time. We don't have to do things individually. Pretty cool, huh? Now, if you'd like, and you certainly are more than welcome to do this, if you want to keyframe everything on the entire thing, oops, I hit the wrong button. That was silly. It's pretty easy to do that, okay? Let's go back to frame 1. Now, we need to make some selections here. You could, if you'd like, go in and keyframe all of these guys. You're more than welcome to do that, okay? Also, if you hit the Y key is going to bring open your item transform tool. And the item transform tool is automatically going to select the position, rotation, and scale channels for you. If you look carefully at the tool handles in the item transform tool, you can see that here's the move, here's rotation handles, and the cubes that over here at the end allow us to scale. So the Y key is a great master tool, if you will, that will allow us to very quickly go in and keyframe all 3 parts of our transformation channels together at the same time. Now, if you'd like, you can hit the S key. S for soccer or September. The S key is the keyboard shortcut to keyframe the selected channels. If the item transform tool is on, technically all those channels are selected, and it's a fast way to key everything. In addition to that, if you only want to key like scale values, that's something we haven't done yet, okay? Maybe I want my teapot to get smaller along its animation. Check it out. This is another option that you can have. You can fire off the scale tool, which is the R key on your keyboard, and then hit the S key. Now watch what happens when I hit the S key with just the regular good old scale tool turned on. Bloop. Oop, I hit the wrong button. I hit R again. And, oh, I turned it off. There we go. Now, okay, I take that back. I guess it's not going to allow me to do that. However, once a keyframe is enabled, you can continue to use that tool to change its size just with the tools themselves. It's not going to let you key it like it is the item transform. Now our teapot gets smaller. That's kind of cool. Questions on how to work with this? There's one final thing that I want to talk about before we start talking about rendering, because rendering is going to be a big thing that we're going to be doing in here. Okay? Every animation that we produce, we're going to render. It's part of our workflow, but there's one final thing that I want to talk about. And to do that, let's just get rid of all the animation that we've created on my little teapot. Okay? Now, one of the things that people get confused about is understanding where their keyframes are currently residing inside of our three-dimensional scene. Check it out. What happened to my keyframes? They're gone. Do you see any keyframes on my timeline? No. Why? The teapot's not selected. These keyframes only reside and are stored on the item that we were animating. So if I wanted to go back in and change the animation of my teapot, I got to go back in and select my teapot. The moment I select my teapot, check it out. Bump, 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 bump. Bloop. There it is. There's your blows. I select my teapot. All the keyframes that are on that teapot come back to the surface, and I can do some wholesale changes to these now. Okay? I can go in and do some pretty big sweeping animations or sweeping changes to my keyframes to get whatever the result is that I'm after. Now, for me personally, I want to delete all the keyframes that are associated with this animation. I basically want to get back to square one. Here's a fast way of doing it. Start at the end of your animation. Then you just go in and just uncheck all these little red dots. That will get rid of those keyframes. Okay? Let's go back to the previous keyframe on frame 60, do the same thing. And then one last time over there, just get rid of all these guys. Now, if this is a monumental pain in the rear end for you, I believe you can also select the keyframe in your timeline, right-click, and then you want to do delete related. Boop, and it's going to go away. Okay? So now we've removed all the keyframes from this item, and we can continue working on it. All right. Final thing, and then we'll take another little break, because I apologize for lecturing for so long today, but this is kind of like the most important foundation piece of our entire animation engine. Okay? All right. There's one more thing that we got to talk about when it comes to animating, and this has everything to do with your homework this week. Okay? And that's the center point. When it comes to animating objects, as I mentioned before, we're kind of really not animating vertices, edges, and polygons. We're animating an item. In the modal animation system, each item is given an item center point. And this center point is really responsible for, not the center point, the pivot point. I apologize, the pivot point. There is a center point. The center point is, in every sense, kind of a representation of the center of the mesh. But we want to animate the pivot point, which is an animatable element inside of our scene. It's pretty neat. The pivot point is really responsible for rotating our object inside of the scene. Okay, and it's pretty great. It's responsible. I need to rephrase what I just said. It's really responsible for animating our item. Okay. It's going to drag any sort of mesh, component piece along for the ride. Let's visualize the location of our pivot point. If I click on my item, then hit the number 6 key on my numbers, my top row number pads, that right there, that little thing in the center of my teapot is its pivot point. Pay really close attention to its user interface. Okay? It's a little checkerboard circle in the center. This is different, very different from that of an object's center point, which technically we also can move. The center point is a disk like that. The center point represents the center of a mesh, the center of an item. If we want to change how that item animates, we're going to want to change its pivot point. Okay? Let's go hit the number 6 key again and check it out. With that, I can select my pivot point. And now, using the item transform tool, the Y key, I can change the location of my pivot point. See how they also draw a little line here between kind of the area or the location of rotation, scale, and translation to the center of the mesh. Okay? Watch what happens now when I go back into item mode and hit the Y key. Now, I'm in item mode now, not in my pivot point selection mode. Where are my tool handles showing up? On the pivot point, okay? So in every sense, if you really take a step back and look at what we've created here, the pivot point really defines where our item moves, rotates, and scales from. Now, this is pretty handy because we can create some pretty complex animations pretty quickly. So now I can have something swing around a defined center point, okay, a defined location. Now maybe I want to have a nice, soft, sweeping curve somewhere. I can use an offset pivot point to do that. Making, and let me show you a really fun example here. So maybe I want to animate my object going along the z-axis over the course of 120 frames. So this is, oops, I just grabbed my camera. There we go. So here's my animation at the moment. Woo! Just goes that way. But with my pivot point offset, as it was a minute ago, look at what I can do now. I can create this real kind of cool corkscrew spiral effect really simply by going in and animating the Y rotation channel across the same range of frames. I'll put 720. So it does 2 full rotations. That would normally be a rather difficult animation to create without the edit of the location of that item's pivot point. Okay? So the pivot point is really, really, really the item inside of our animation engine that's actually moving, right? It's the one thing that's kind of actually going from point A to point B. It's the polygons are kind of being dragged by the location of the pivot point. Okay? The pivot point is responsible for animating the mesh. Okay? Now, if I add more geometry into this mesh item, and this is kind of illustrates this idea pretty quickly. I'm going to go back to frame 1 here, and I'm just going to return to my component, or excuse me, my modeling layout, and check it out. I'm going to add a box into this. And don't worry how I'm doing this. This is not the point. Okay, so I've just added an additional piece of geometry to this mesh item. If I return to my item or my animation layout, check it out. Yep, everything comes along from the ride. Okay, whatever's on that mesh item is going to be animated. Okay, we can continue to add component pieces after keyframes have been applied, for whatever reason. Okay. Changing the location of our pivot point is something that you're absolutely going to want to do, okay? Because the pivot point, especially in the larger context of this week's homework assignment, is something that we're going to want to change, okay? Questions? Let's explore this one more time, okay? I'm going to go back to frame 1. And grab my item. Okay, you have to select your item first. To go into pivot point edit mode, hit the number 6 key on your top rows of your numbers. And the pivot point for the selected item, oops, I zoomed in too far, is going to come out. There it is, right there for me. Okay, you can select it, and you can move it around. Watch what happens when we move it back this way. This is going to be a weird, wacky animation now. If I play my animation, look, the pivot point is still moving just straight forward, but it's rotating as well. Cool, huh? Let's do it one more time. Grab my pivot point, move it up. Now it's going to rotate around that point. Well, I don't have any sort of Y rotation, so it didn't really change the appearance of it. What's cool about this is that you can actually animate the pivot point's location. Okay, it's kind of an advanced thing. I think you have to go into your channels, but you can do it. You can do it. Let's see if I can try doing it real fast. Well, I don't want to confuse you guys, but you can actually animate the location of your pivot point on the object itself. It's pretty neat. That's one of the reasons why the Moto animation system is so powerful. Cool, huh? Pretty cool. Okay, I think what I'm going to do here is let's just take another small little 5-minute break. We'll come back and we'll talk about rendering and start in on our lab. Does that sound good? All right, let's take a break. So please be back in by no later than 11:55, please. Okay, so before our small little short break, we were working with the animation engine and we were changing the pivot points of some of our items. But now we're going to fast forward a little bit here. We're going to pretend that we're all done and we need to render. And this is where it's going to get a little bit weird and a little bit funky, okay? Because rendering animations inside of Modo is not hard, but it's not exactly the simplest thing either, because it's really a two-phase process. We're going to be rendering what's called an image sequence inside of Modo. And then we're going to take that image sequence over into After Effects and then finish our render over there. Before we go too much further, I think it's really important to point out that I've created a self-contained video for this subject inside of the Week 2 module. So I know that a lot of folks get confused because there are a lot of steps in this process. Please make sure you revisit rendering animations in Modo and rendering image sequences in After Effects, okay? This is going to help. This is going to help. I'm going to go over it together in class, and then, here it is again online, all right? It's really not that bad, and I know you can do it. All right, let's jump back over into Modo real fast and start talking about rendering. So for your homework this week, for your coin flip and for your solar system, you're going to render something, okay? First things first, though, we got to find our animation. There it is. Down here in the bottom, we're going to compose a shot. Now, what we see in the bottom part of our window here, if your OpenGL viewport has been changed to look through your camera's lens, what you see down here in every sense is going to be what is going to be rendered. And there goes my weird animation. Here, you know what I'm going to do, just to make it a little bit easier? I want to make a new scene file. And this is exclusively just to make it very, very simple. I'm going to grab a teapot, and I'm going to animate my teapot just going forward. Over the course of, I'm just going to do 24 frames. That way we're not sitting here watching it render forever. Okay? So my scene start, scene end is going to be 24. There we go. All right, let's go back over into our render layout real fast and compose the shot. Here, we'll put it from this side so it's in the light. All right, so now inside of my animation render window, I can see the totality of my movement, okay? The goal here is to export or render our animation so that we can preview it on Facebook or on YouTube or cut it into a film. Right now, our animations only and exclusively reside inside of Modo. So we need to render and ask the computer to draw the picture so that we can include it in something else, okay? So we can put it in a film or a television show or put it on the web or in a video game, okay? This process is called rendering, where the computer physically draws the frame. Now, we're going to have a lot of conversations about rendering over the next 15 weeks, so this is not the conclusion of this, okay? But the first part that I want to just show you real fast is the role of the preview window at the top of our screen here. It's black initially with a big white triangle on the inside. If you hit the white play button triangle, you'll see pretty quickly a small, actually pretty high quality preview of your animation, okay? So there it is. If you move the playhead forward, you can actually get an update. Things are looking good. Awesome. Very nice. But this is not the actual render itself. It's a preview. That's all it is. It's just a preview. We need to ask the computer to go in and do a full-blown render to physically draw the high-resolution frames that we're going to need to compile our image sequence over in After Effects, okay? If you've taken GCOM 402, or any of my 3D classes for that matter, this button right here is often the button we go to render our animations, right? What's that one button going to do? It's just going to render a single frame, and it's only going to render the frame that my playhead is currently sitting on. And for me, I think I'm on frame 1 or frame first. Yeah, frame 0 of my animation. So if I hit the render button real fast, The render engine is going to come online, and poof, it's going to draw my frame. But I've only drawn one frame. I need how many? 24, okay? We're going to be producing what's called an image sequence. It's really going to be kind of like a stack of drawings, okay? A stack of pictures. If you think about it, go back to the good old film days, okay? Let's pretend you have a film camera sitting in front of you. You crack open the film camera, you take out the negative, you hold it in front of a piece of light, and what do you see on that film negative? A whole sequence of individual pictures, right? And when we play back those pictures at a defined frame rate, we create the illusion of movement. Our rendering engine is going to be producing a whole sequence of images for us. Let's check it out. Let's understand pretty directly how we're going to do this. So we're not going to go to this button to render our animations. Instead, what we're going to do is go to the Render pull-down menu at the top of the screen. And then there it is, Render Animation. This is going to fire off what's called an offline render of our animation. But what's different about it is that once it's finished rendering the first frame, it's automatically going to advance the playhead forward and render the next frame. Then once it's done, move the playhead forward and render the next frame. So on and so forth until the entire range of animation frames are finished. Let's go ahead and do it real fast. Let's hit the Render Animation button. You're going to get a little popover, and it's going to ask you which range of animation frames you want to render. Now you need to look very, very directly at this, because if the developers at the Foundry are listening, like seriously, they need to fix this. Okay? Look at what the computer is asking us to do. What are the defaults? It's going to render from which frame first? Frame 1. And then when is it going to stop? Frame 120. Let's look at our timeline. How many frames do I have in my timeline? 24. Okay? So you need to be very, very mindful of your timeline settings. Okay? Like you really, really need to dial this in. Because right now, check it out. My timeline starts on frame 0 and it goes to frame 24. So if I just leave the render animation defaults as is, it's going to render frame 1 to 120. So what's going to happen on frames 25, 26, 27, 28, 29, 23? What's going to be produced? Blackness. It will actually render black frames for you. We don't want to do this, okay? This is a landmine that will blow up in your face if you're not careful, okay? You have to make sure that you're rendering the range of frames that you have animated. So I'm going to go up into my render animation settings again, and naturally I'm going to put 0 to 24. There we go. Now the frame step is something that you should never ever really change, okay? The whole idea behind this is that when this frame step value is set to 1, it's going to render every frame in sequence. So it will render frame 1, then 2, then 3, then 4, right? It's going to step the playhead forward 1 frame when it's finished rendering its current frame. If I was to change my frame step to 2, when it's finished rendering frame 1, it's going to step the playhead forward 2 frames. So it will render frames 1, 3, 5, 7, 9, so on and so forth, okay? If I was to put the frame step to 3, then it would be 1, 4, 8, so on and so forth, okay? You never want to change this. Never want to change this. Just leave it at 1, okay? In addition, we're always, always, always going to be rendering an image sequence. Not a movie, an image sequence, okay? This is a muscle that we're going to build. Yes, it adds an extra step. But trust me when I say that this extra step protects you, okay? Here's why. When you render an image sequence, when the render engine is finished rendering that frame, it's going to save that frame to disk, okay? If you were rendering a movie file in that settings, it's going to render a frame, but then it's going to save it into a temporary cache file until the entire render is complete, okay? And then when it finishes rendering your last frame, it's going to take all those temporary frames, compile it into a QuickTime movie, and then permanently write that QuickTime movie to disk, okay? When we render movies, we run the risk of losing everything if there's a crash, okay? And render crashes happen often. They're not going to happen for this assignment because you're asking it to do very, very little, okay? But I think I've shown you some of the examples that I've done recently. That big train model that I finished painting and rendering, I rendered that a whole bunch of times before it, and I had to optimize my render before it actually finished, okay? Because I kept getting crashes, and I kept getting out-of-memory errors, and it kind of turned into a beast, right? I lost a lot of work because my scene wasn't optimized. Renders happen all the time at crash, okay? Or crashes happen all the time at render, okay? Let's pretend you're working on Rogue One, okay? You know, there's some of the most expensive visual effects I've seen to date are in Rogue One. They spent a tremendous amount of cash on those visuals, okay? You better believe that they're paying attention to how much time they're spending on rendering because there's a dollar sign associated with it, right? When you render image sequences, the moment it's done rendering a frame, it saves that frame. So if you're rendering 100 frames and the computer crashes on frame 95, do you have to go back and re-render 1 through 94? No, you don't, because the moment it's done rendering a frame, it saves the frame to disk. So if it crashes on frame 95, all you have to do the next day is go in and render 95, 96, 99, 98, 99, 100. Okay? It saves you. It is your insurance policy if there's a crash. Okay? Because there's nothing worse than trying to render a movie out of Modo or any app for this matter. This is not a problem that's limited to just Modo. Happens even worse over in Maya, right? There's nothing worse than spending all night rendering to find out that you've gotten to like 98% done and the computer runs out of memory so the app crashes, right? You have now lost an entire night's worth of rendering, okay? If you render an image sequence, you only lose the work that wasn't completed, right? You're always going to have the stuff that was previously rendered, okay? It is our grand insurance policy in 3D, okay? In addition, when we work in the higher end, in the visual effects world, where our computer frames, our computer render frames are going to be integrated into a compositing system, well, the feature film guys, they work inside of a frame system already, so it allows us to kind of work together pretty directly. All right. Long story short, you're always going to be rendering an image sequence. Let's just do it real fast. It won't take too much time, okay? I'm only rendering 24 frames of animation, and it's going to be wicked fast. So once you hit that OK button, the next thing that it's going to ask you to do is to go in and give it a name and a location. Okay, first things first, you want to put this inside of a folder. Remember, the computer is about to make individual pictures, okay? If you have these individual pictures saved to your desktop, you're going to have like potentially 300 pictures on your desktop when the render's done. Put it in a folder. That way you're managing your media a little bit more intelligently, and you're efficiently moving through the render stage into After Effects. So here's what I'm going to do. I want to make a new folder. I'm going to call it Test Render. Put R&D for render. I'll put Test R&D as the file name with an underscore after it. And I want to save, let's just do JPEGs. For the time being, JPEGs are a really great thing to use. For this week's homework assignment, I want you to render JPEGs, okay? It's not the file format we're going to end with, but it's a good one to begin with. And then, once you got all this stuff set up, hit save. And the computer's going to take over and it's going to start rendering each animation frame. There's frame 1, there's frame 2, so on and so forth. Now I'm going to do this fast. Now what's cool about this, and it proves my point, if you go to your desktop and look at that frame, that folder that I created, you can actually see all the rendered frames showing up going into the folder as the computer's done drawing them, right? Further proving and showcasing that the moment a frame is rendered, it saves it to disk, okay? Which is great. We like this. We love this. We want a lot more of this, okay? And luckily for us, our little animation is incredibly short. Only a couple more frames here before it's done. So we're going to let this sit and cook. The animations that you're going to be creating for both your homework and your lab this week are going to be very, very short. They're not going to be, animations that you're going to have to commit 45 minutes or a couple hours to. It should go pretty fast. And there it is, folks. I'm done. Woo! So this is what is created. A whole stack of pictures, okay? The whole stack of pictures. Get used to seeing, this is called an image sequence, okay? And they really are a JPEG like any other JPEG. If you double click on an image, it's a picture, just like any other picture. That's always going to be the product of our rendering engine here inside of Modo. It's always going to produce a picture, okay? All right, with that said, let's jump over into After Effects real fast and talk about what we're going to do with this. Because clearly, we can't upload an image sequence to YouTube. We can't do anything with this image sequence over in Facebook. We have to get it into a common media file that the rest of the world understands. Image sequences are just for us in the 3D world, okay? And for some feature film guys and gals too. But we need to get it into a common video format that everyone else can play with, right? Because I definitely want to post this on Facebook, okay? Thus enter the role of After Effects. We're going to be looking at After Effects often over the course of the next 15 weeks, as in every sense, it's our grand Swiss Army knife for us in the video and film world. If you're an image editor, if you're a graphic designer, Photoshop is your big Swiss Army knife, right? It's that one super tool that has all the features and functionality that you're after. For us in the video and film world, After Effects is our Swiss Army knife. Here it is. We're working with Adobe CC 2017. However, if you're working on version 4 of Photoshop, okay, this functionality is built in. So let's just go ahead and launch the app real fast. It's really, really easy to do what we're about to do. It seems scary and weird, and it will be uncomfortable the first 1 or 2 times that you do this, okay? However, remember, for us in the professional media world, get used to being uncomfortable. Get comfortable with the idea of being uncomfortable, because that's every day of your future, right? The technology that we leverage and manage is pretty intense, okay? After Effects is a beast, by the way. It always takes a long time to load. Although they have a really great, cool cover graphic now for this version of After Effects. It's pretty neat. I like it much more than the previous one, which was like a barn exploding or something like that.
It was like a barn exploding with the moon behind it.
A little kid in there or something, yeah. This is pretty neat. I like it. After Effects is a professional motion graphics and video application. It's one of the original motion graphics and video applications of our industry. At times, it's going to feel very dated because it really does go all the way back to the mid-90s, okay? And the first time you load it, it takes a while to launch. So here we go. I got an idea. I got a hunch that things are about to start in After Effects. I think this might be the first time After Effects has been launched this semester. Ha ha. Okay. Welcome to After Effects. Welcome to After Effects. Now, this is not an After Effects class, although we are going to learn to use After Effects a little bit, okay? So I'm not going to go into all the bells and whistles. We have a dedicated class devoted to working inside of After Effects. It's GCOM 390. So if you're really interested in working in motion graphics and building animations in the computer, and 2D animations in the computer, After Effects is a great program, and GCOM 390 is a wonderful class to take. I've taught it in the past. However, I'm not really teaching it this time around. But let's talk about how we can start our project or start our work here inside of After Effects. We're going to use about 0.1% of the features inside of After Effects. We're exclusively going to be using After Effects to import an image sequence and then render that image sequence as a movie. Here's the process that we're going to follow for the next couple of weeks inside of After Effects. We're going to go to the top of the screen where it says File, and we need to import the image sequence that we just created over in Modo. Please note, though, that I'm doing import file, not underscore, highlight, and circle in your brain multiple files. We are going to import one thing, and After Effects is going to take care of the rest for us, okay? Remember, just one thing. Once we click on the button, we're going to navigate to where we stored all of our animation frames. Now, I remember that I put mine on my desktop, and I called it Test Render. Here's the rookie mistake that everyone thinks that everyone makes. They import the folder. That's not what we want to do. what we need to do is open the folder and then select the first frame of our animation. So I'm simply going to double click on the folder to open it up. And here's the first frame. I'm going to select the first frame, not all of them, just the first frame. Okay? Because check it out. After Effects is a pretty intelligent system. When you hit open, it recognizes that all the files inside of that folder are a sequence, that the frame numbers are kind of descend or ascend sequentially, and it recognizes it as an image sequence. Okay? If you look at what shows up here in the bin, check it out. It's pretty fantastic. There's our image sequence. If you double click on it, you can look at it over here inside the player. Hitting the space bar will allow you to see it real fast. Rock and roll. Things are pretty great. But we're not done with it. This just allows us to preview our animation to see what's going on. The last thing that we need to do is that we're going to grab our image sequence, okay? And this is what it should look like, okay? If you see a bazillion images in a row in your bin, you've done it wrong. You've imported each image individually. We want to import the entire stack as an image sequence, okay? So here's what we're going to do, and it's pretty easy to do the rest of this, okay? We're going to go down, and we're going to grab this file, and I'm going to do this just to make it a little bit easier. Okay, we're going to grab this file, we're going to drag and drop it onto the button next to 8 BPC, okay? And that creates a composition, okay? The composition is kind of the working unit, if you will, instead of After Effects. It's kind of like a canvas over in Photoshop or a stage in Adobe Animate, okay? And we're not really going to do anything with it. We're just going to leave it as is. And then and if you look carefully, this is the icon for your image sequence. This is the icon for your composition. With your composition selected, here's what we're going to do. File, Export, Add to Render Queue. It's going to bring open the render queue down here at the bottom. Okay? And the render queue is really our After Effects rendering environment. Okay? It allows us to very easily and very quickly go in and set up a render to create a movie file from a stack of pictures. There's two things that we need to change: the output module and output 2. The output module, which is on the second row here, is responsible for creating the actual movie file. This is what it's going to do. So if I click on the word lossless, not the arrows, this is bad. We don't want that. We want the word lossless. Click on it. It's going to open up a little popover. We just need to double check a couple things here. Okay? First and foremost, the format. This is the type of movie file that After Effects is going to create for us. Now, if you're doing this at home on a PC, this format is not going to be QuickTime. It's going to be the dreaded AVI. Okay? AVIs are horrible. It's probably one of the worst video files on the face of the planet, only surpassed by the Windows media file. Man, that thing is just so bad. Okay? It compresses the image pretty poorly. The file sizes are huge, and it's generally, and I'm going to speak very plainly here, not supported in the professional level. QuickTime movies are the gold standard. It's what everyone uses out there in the real world. So we want to make sure that we're rendering a QuickTime movie. Now, one of the other things, and this is just for us in this class, we need to change the format of our QuickTime movie. Click on Format Options, and under the Video Codec pull-down menu, we want to choose from this crazy long list H.264. This is going to compress your file. It's going to make it very small in file size. It gets it into the correct format and codec for you to publish on YouTube or Facebook quite instantly, and it's going to do a great job of preserving the quality of your image as well, of your movie as well. It's a good codec. We use it for everything. Once you change the codec of your video file, we'll hit OK, bloop, and then one more time down here at the bottom, and we're done. Now, the output module just sets up the parameters for our render. We actually haven't done any work yet because there's one more thing that we need to change, and that's the output 2 section of that exact same row. The output module determines the parameters. Output 2 gives it a file name and a save location. So let's go ahead and give it a file name. And I'll just call this test render, and I'll put it right on my desktop, and I'll hit save. Now, have I rendered my animation yet? No. The last step is that gigantic render button on the far right-hand side of the frame. This little render button is going to take all the details that we just kind of laid out and use them to render our final animation. Let's go ahead and render it real fast. It takes about 2 seconds. You know you've got you've done everything right when you hear the little ding. Bling, it's my happy render sound. And if we return to my desktop, there it is. There's the QuickTime movie that we saved from After Effects in the correct format that we now can share out there on the web. So this is the product. This is the product. This is what we're after. I'm going to apologize. What was your name again? Don't delete those. What was your name again? Adrian? I want to show Adrian did something that I think is really entertaining. And Adrian, in the top right-hand corner of your computer screen, you have a number. What computer number are you? 20. Adrian made, I don't want to call it a mistake, but he did something that I think the rest of the class can benefit from. I have some awesome technology in this classroom, and I can spy on you guys from afar. Adrian was just rendering out some animation frames, and look what happened. What didn't he do when he rendered his animation frames? Put them in a folder, okay? Those folders are really important because otherwise you're going to get this, okay? You're going to get this. Your desktop is going to be flooded with individual images, and that makes it a challenge to work with. You'll have to go into the Finder app, make a new Finder window, sort it by list view, and then put it in a folder. Kind of adds a couple extra steps that are relatively unnecessary. Thank you, Adrian. I apologize. Now you can delete them all. Make sure you don't delete your hard drive. That would be bad. All right. So keep in mind, this is a 2-phase process. We're rendering at 2 different levels. We render inside of Modo to get our image sequence, all of these guys. And then we roll it through After Effects to get this, okay? This QuickTime movie is what you're going to be submitting in addition to your Luxology project file for every single lab assignment and for every single homework project that you do. Do not, under any circumstance, give me your image sequences. I don't want 500 image files in the Dropbox, okay? I don't want to deal with that, nor do you want to deal with it either, okay? So we're always marching towards producing a QuickTime movie in After Effects that will upload to the assignment sheet in Canvas in addition to our Luxology project file, okay? Now, I recognize firsthand that that is a tremendous amount of procedural, sequential information that one needs to digest, which is why I made some dedicated videos on Canvas to help you guys walk through this process. So I know I mentioned this before, but really go check these out, okay? They go over everything that I just talked about, okay? Or go watch the live stream, which will end here in a moment, and you can revisit exactly what we did in class. Sound good? Everyone good? All right. Let's spend a couple seconds here looking at what you're going to be striving to complete for your homework this week, okay? Because you have your homework and a lab assignment. They both won't take too long, but let's take a look at both of them. I'm going to go to the top here. And let's just start simply with your lab assignment. Because in every sense, your lab assignment is a project that's kind of similar to what we did in class today. And this is the coin flip project. And the expectations are that you download the resources that I provided you and that you animate it going from the left side of the screen to the right side of the screen. In addition, it also needs to flip. And here's the great example of what we're looking for you guys to produce. Okay? So I want you guys to animate the position and the rotation of this object. At the conclusion of this animation, render it from Modo, compile your image sequence in After Effects, and produce a QuickTime movie in addition to your Luxology project file. That's the goal. I've given you the project file that contains the little SEC coin here. So if you take a look at it, let's just download this thing. Take a look, see? There it is. There's the coin. So this is everything that you need. You really shouldn't need to change the camera's composition down here at the bottom. Remember, you're going to do all of your work inside of the animation tab. All right? So this is the environment where you're going to be animating the logo itself. Just a simple flip. That's all we're after. We're moving and rotating at the exact same time. Okay? And then render your animation when you're finished. Okay? Please note, 50 frames. 50 frames. It's not 120. 50 frames for your animation. So what do you need to do inside of your timeline in Modo to get this down to 50? Change your timeline settings in the animation layout. You got it. So don't forget to do that. That'll save you some render time. So keep in mind, the default settings go from 0 to 120. For this assignment, it needs to go from 1 to 50. Change that first. Change that first. Before you animate a single thing, get your timeline dialed to match the length expectation of this project. That's your lab assignment, okay? Should take you 2 minutes to animate and 10 minutes to render. Yeah?
Maybe some sort of preview window could be opened, so you could adjust.
Yeah. Yeah, absolutely. So if you want to preview what the render is going to look like, return to your render layout. In this gigantic thing at the top of the screen here, Liam, this is your preview. If you click on the little white triangle, the play button, if you will, you'll get a preview of the current frame. All right, so that's your lab assignment. Like I said, it shouldn't take too long. You also have a homework assignment this week, and that's the solar system. The solar system is a little bit more fun. Let's look at the contents of our resources here real fast. I'm just going to put them all on the desktop. I like things going on the desktop. All right, so here's the solar system files that I've given you guys. And if you look specifically at what's going on, you have the project file. Now, when you open up the project file, it's going to ask for some pictures. It's going to say, hey, I need to find the solar system scale JPEG. Do you have it on your computer? Yes, it's in that bundle of stuff that I've given you. So if you hit yes, it's going to open up a Finder window. Go navigate to where you saved all the stuff that I gave you guys. So there it is, right? It's that one right there. Oh, wait. Maybe it's not that one right there. Let's go back into the model layout and see what's going on here. It will also link all the textures for your models. Okay. So each model or each item is its own planet. Your job is to animate the solar system, animating all the planets traveling around each other the way they normally should. Okay, and they're all in there. They're all at the origin. So you're going to have to figure out, based on what we talked about today, how to move these planets into their appropriate location and to get them traveling around the sun, which is this guy. Okay, in addition to all the JPEGs, here's their actual flight paths. If you want to get super nerdy with this, I say go crazy. This is not to scale, by the way. Okay, it's just a representation. We are not trying to recreate the solar system, but bonus points will go towards the folks that will actually recreate the solar system. Because yes, you can do it. However, if you render it, you're going to see that you're going to be rendering the smallest little dot. Someone did this last semester, and I thought it was, or last year when I did this, and it was very entertaining. They actually found the real distances between the planets, and then they moved our little planets those exact distances in Modo. And it was fantastic because we actually made a scale model of the entire solar system. They made the planets their appropriate size. It was really kind of neat, but the render was horrible because they tried to fit the entire solar system into one composition, and they're just like one pixel represented the sun, another pixel was moving around and it represented like Earth. So, anyways, question.
Is Neptune supposed to be on the same rotation as Pluto?
No. Say again?
I was just asking if Neptune was supposed to be on the same orbit as Pluto.
No. And for a second there, I thought you said something different, and that's just a mistake.
Okay.
Yeah. Yeah, I think if I remember when I drew this, did I actually draw paths? I missed one. I missed Pluto. I didn't draw Pluto's path.
No, you have Pluto's path. It's just
Neptune's on.
Pluto's.
Neptune's on the wrong one. Neptune needs to be down one. Okay. Yeah. I don't care about Pluto. It's not a real planet anyways. Has anyone heard? I love how like Pluto goes back and forth between being a planet and being a celestial body, right? Yeah, it's like can the astrological or astronomy, not astrological, that's something else, right? Can the astronomy community come to a conclusive, science, fact-based decision on whether or not Pluto is a planet or not? I just want to know what it is. I'm being silly at the end of the day. They keep arguing over it, right? We're just like, come on, guys, really? Anyways, all right. Questions on what your job is to do. This is a puzzle. The solar system one's going to be a puzzle, okay? I'm specifically not giving you all the answers to the puzzle because I want it to be a challenge for you guys, okay? However, massive hint, pivot point, pivot point, pivot point, okay? Edit the location of your pivot point. You'll find that it's pretty easy to do it after that, okay? All right, questions about the expectations over the next 7 days. So over the next 2 weeks, you're going to return to Canvas and submit your homework and your lab files. It's one of the cool things about working inside of Canvas. You're going to go back here, and in the upper right-hand corner of your Canvas assignment sheet is this button, which will allow you to submit both your Luxology project file and your rendered QuickTime movie. It'll take you to the bottom of the page where you will choose a file, and I'm not going to do this, but let's just say there's my coin flip. I'll hit open, and then we'll choose another file, and we'll do my test render. And then you can say, this is awesome. I'm all about subliminal messaging, right? No, you don't have to do hashtag Professor Pat rules, but that would be cool. You don't have to give me a comment. You don't have to give me a comment. If you feel like you need to communicate something to me about your assignment, then you're more than welcome and encouraged to leave me a comment. But your job isn't done until you hit that Submit Assignment button, okay? You only attach these files to your submission, and then you hit the Submit button, you're good to go, okay? Sound good? Everyone confident, clear understanding of what's going on over the next week? All right, rock and roll. Good luck. May the force be with you. I'll see you next Friday.